Yo. Hello, hello. And we're going to maybe read this thing today. But first maybe I do something. Not sure what. With my programming language. What was the last thing? You're currently bisecting? Wait, what? I'm not bisecting. Place mutability. Yeah, I was making the mutability. Oh, wait, hold on. Forgot the notification. Hello, Nerdsel. Yeah, so like I was like trying to make this actually I was writing this comparison with Rust, right? And then it just starts with the thing that is not actually implemented, which is very weird, right? But actually implementing this properly is not that easy, right? Because we need like a full borrow checker for that. That's what we realized. Let x be 0, x be 1, places read only. Yeah. This kind of works, but only for simple cases now, right? Yeah, because if I say let x be 0 and 1, then I can say that x dot 0. Yeah, let's do this actually. Let's do this. Let's do simple thing where if I have a tuple, then I should be able to say dot 0 for the first element of a tuple. So this expects right now only identifiers, the field x's, but we should also be able to get the numbers. How about that? This is a good thing to do. We have field access over here, and it expects an identifier, right? But I want to have not only identifiers, I want to be able to have them as okay, so what do we call this? What are they called in Rust? Let me see. Docs cd syn in the syn crate. What's it called? Index. An index of an unnamed tuple field struct. No. This can be a part of something. Ident fragment. What's ident fragment? From quote. From index. Oh, member. This is what it's called, right? They call it member. It's either a named member, which is identifier, or it's unnamed, which is just an index then, right? That's what we want. Yeah, so let's just have this thing then. where, yeah, I think we have this tuple crate, right? Or is this just in the utility? Yeah, it's just in the utility. So we have the tuples here, and we have special methods called get named and get unnamed, right? But instead, I think I just want to have like get member, or like just get, and get member would be just, you know, member, like this. Option D, right? Get unnamed just returns all of the unnamed at the same time. Why is that? Instead of getting by index. Unnamed, named. Yeah, this over here is weird. So what's this member? A member is an enum. It's either unnamed with the index, or it is named with the identifier, right? An identifier would be stir, which means that this has the lifetime like that, I think. And we get this lifetime, and that lifetime doesn't matter, right? Yeah, so we just do match number. If it's unnamed index, then I return self get unnamed index. Otherwise, if it's named identifier, then we do self get named identifier. I think just like that, and then get unnamed. Is this even being used anywhere? I don't think this is used, so I just make this. Take the index, and this should return also optional t, right? So this would be self unnamed get index. Dun, 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 dun. Tuple member is more private. Yeah. It should be public. I can derive, debug, hack, clone, copy, hash, whatever. Okay, so we can get this is just getting. Is that enough? I don't know. But basically over here, this should be so we have field as an AST, right? And I want this to be converted into a member, right? AST as member. AST as member field expected expected a member, expected member, and or member, and or index dot field. Yeah, something like this. And then we have this thing somewhere. How big is this file? 3,000 lines. Nice. Yeah. Sure. Implement, no, function is t as member. Option. Sure. Expected option unknown. Cargo clip is in progress. Can't find member in scope. Util. Maybe I just need to. I'm not really exporting it or something, right? Yeah, I just say this tuple. Let's say like self. The name tuple is defined multiple times. What? No, it's not. I mean, okay, but in this case, we need to make it public mod, right? So then I would just say tuple member like this. Okay, so and then we say that match is t, right? This must be a simple one. Is t. It should be a simple token, right? And then I'm going to match token. Right, we have these, so I should only support numbers and identifiers. Yeah. So if this is an identifier, name, raw. Okay, this would be raw parse. Okay. This is the index size, and then I return some tuple member unnamed index. Right, and this over here would be tuple member named name. So there you go. Now we have a field. Okay, and then I want this member to be owned actually because I want to store it, which means that the tuple member, I think this should not have a lifetime, but then I mean I can do a cow here, right? std a cow, I guess. And we can have the owned one. But cow does not implement copy. Yeah, sure. So in this case, identifier is a cow, and we just say identifier as ref or something. So yeah, in this case, so yeah, this will be with lifetime. Std borrow how borrowed name like this. Are my plants alive? Yeah. Yeah, you don't see? There is like flowers growing on them. Okay, so field access over here, field is going to be a member, tuple member static. field field to owned. Yeah, let's have a to owned there. Yes. Implement member this public function to owned. This will just into owned, I guess. Self with this will just return member with static lifetime. Right. Match self unnamed index. Named index. Over here we say named identifier dot into owned. No, not into owned. What's the called the thing on a cow? Methods into owned. Oh, this extracts the owned data, right? I want to make sure that it is owned now, right? How? To what is owned, is borrowed? There is no method like that. Why did they not make a method? Well, I mean, I can do, I mean, because it's going to be a different type, right? So we do into owned, and then we say std borrow cow owned, right? Because it's a different type because of a different lifetime now. Makes sense. Okay, and now over here we say fields get named, right? So instead of this, we just say fields.get, and then field is this member, right? But I want to say field dot as a ref. So similar to into owned, I also want to have a function as a ref self into member like this, right? So instead of having I do this, I match this by reference, and then we instead say borrowed ident, which is going to deref automatically, right? And then over here, when we're doing field access, we just say fields.get field as a ref. And then over here we say definition name is equal. Wait, what? Oh, it's syntax definition. Yeah. Definition name string is equal to field. Yeah. Tuple member named defin std borrow how borrowed definition name is equal to the field. I call them fields here and a member over here. Is that weird? Member does not implement display. Why did minicast pop up in my GitHub notifications? I'll tell you in a second. That's as a proof of concept of a thing that I want to do. And to implement display for the member. Yeah. Implement std empty display for member. Match self. If it is unnamed index, then I just write f index. It is this with ident, and we write f ident, like so. Fun fact, today is actually a reading day. Yeah, I'm just stalling here. Looks like the language implemented with Decal macros. No, that's not the idea. That's not the idea. Anyway, let me see if I did this just to check. So I was doing the tuple access with index. So we can say tuple is 1, 2, 3, right? So tuple is a tuple of 3 elements, right? And we can say tuple.0, and it's going to be 1, right? Tuple.1, tuple.2, tuple.3 will say that does not have field unnamed 3, right? There you go. So this is just getting the field out of a tuple now, like so. It's not allowing me though to initialize the tuple with this syntax. I cannot do tuple 0, 1 and 1, 2, right? I cannot do that. This still must be an identifier. This can be changed separately. Lazy git accessing tuple members by index. Okay, so minicast. Yeah, sure. Let's see about minicast a little bit. So you see, when I'm working on cast, right? This is this code is bad right now. I mean, it's not that bad, but it's kind of like difficult to understand. And when something is difficult to understand, what I usually try to do is I want to split it into multiple like crates, multiple modules, right? But how do you split? Like over here, right? We have the language, and this is the AST, right? Or like the intermediate representation is what I call it, right? We have all of these like variants, right? We have the ability to read a place, or to have an if, right? To have a constant, to have a number literal, a string literal, a let, call a function, right? Like all of these different things. I mean, this is just 200 lines though to specify this enum, right? But anyway, so like the idea is to split the language into multiple like relatively independent parts, right? That would each be able to introduce their own ASTs, their own intermediate representation, their own like types, their own values, and then we combine all of those together, and we get the thing. Does that make sense? test. So I mean, this is just an example here of how how it can be done, right? So we want a language that has both lists and has numbers, right? So we want to be able to construct the AST like this, where I have like a number 1 to 3, or I can add numbers together, and then I can also like store those in a list, right? So instead of just having a single enum containing all of the variants that I can construct here, we split this into two separate modules, a number module and a list module. So a number is something that like knows what a constant means and knows how to add two things together, right? And then a list is something that knows how to make a new list and how to push a new element into the list, right? So then our final AST is combined these and that. So we can use all of them at the same time. Does that make sense? Spike. So the number module, it doesn't need to know about the existence of lists at all. And the list module doesn't need to know about the existence of numbers. They are independent. Right? But at the same time, if I want to add two things together on the inside the language, it doesn't mean that I want to be able to add only numbers, right? This should potentially contain the like any other nested expression inside. It just needs to be calculated into a number, right? But it can be anything there. Like for example, it can be an expression that generates a list and then gets like the length of the list, right? Well, I guess since the can I have bidirectional dependencies with trace like that? What do you mean bidirectional dependencies? It's not a bidirectional. So the I guess it's kind of is bidirectional, right? Because over here I am depending on basically I am depending on the final language, right? So I am defining here a part of the language which is dependent on the final language, right? I'm splitting all of the AST into groups to be used independently as libraries for consumption by other languages tools. So basically, expression evaluator is separate from the syntax extension. Expression evaluator is separate from the syntax extension. Well, I mean, evaluator is separate from syntax. I mean, this has nothing to do with the syntax in this example at all, right? I call this intermediate representation, not AST, right? Because we don't really parse the syntax here. Has nothing to do with the syntax. Syntax extension is implemented by evaluator. What's the evaluator? Hold on. So here, so like you see, this module is a number, right? So I want to like put all the code that is about the numbers into this module, right? So what is the code that is about numbers, right? We have some intermediate representation nodes, right, that we can add, and we also need to like implement how to evaluate these nodes, right? This is the eval function. So like the evaluator is here, right? But then the evaluator for the final language, which contains not only these nodes, but also other nodes, needs to be able to evaluate all of those, right? So it's delegating the evaluation to either this evaluator or the list evaluator, depends on which the thing is coming from. Two modules depending on each other. They don't depend on each other. So, I mean, yeah, so the idea here is that we write some generic code, which is generic over, so you say here, like kcast, right? What is cast? Cast is basically the final language. So we make this generic over the final language. We specify the part of the language, but inside of this, it can have the final language. So like KIR is the intermediate representation of the final language. And this is just the intermediate representation, which is like all about the numbers. Suppose I will understand eventually. I was just like wondering if you have maybe seen something like this before. Spike, you're doing a lot of Rust, right? Have you seen this this concept before? I think in general we can, like, it's not just about the enums, right? The idea is that I don't know, like, is this the main idea here, that I'm writing the generic code over the final thing? You tried, Rust fails to compile that? What? This code is compilable. This code works. And then in the flake. I was working on this on Windows. Hey. Make this smaller. I don't need much. I just need a def shell. Distracted at work, were you? I was just too lazy to reboot after work. Why? Cargo run. There you go. So like you see, this is the output, right? We have list value with elements. This is the two elements. We have an integer 1 to 3 and a float 3.0. This is the code that I'm like trying to evaluate here as an example. A little strange to think about it. Yeah, I'm not entirely sure, but like as you see, like this allows me to split the code into two separate like parts, right? And they don't know anything about each other. They might as well live in their own crates, right? So we can have a crate that is implementing a part of the language, another crate that is implementing another part of the language, and then we combine those together. In order to combine, I do that not through the type system, because Rust is not powerful enough, but through the code generation here. But it's basically as simple as like like it ends up being something like this. We have enum, like intermediate representation, which is either a number which contains like number intermediate representation, or it is the list, which is like a list intermediate representation, right? So this is how we get like the combined like final enum representing the entirety of the language. And then similar to that, we have the same thing about like similarly to that, I combine all the values, right? Because a list says that I can have a value which is a list, right? And then a number says that I have a value which is either an integer or a float, right? So now all of the different values that the language supports are integers, floats, and lists, right? We just merge all of those together. Right. So one thing I'm not like entirely sure about though is let's say that I have a like another module like strings, right? Let's have a string module here. String. So a string would be I think I need to like reload the Neovide because I added the flake. Yeah, there you go. So the Rust analyzer works. Maybe I could have started it with a command. So yeah, let's say that I want to add the strings, right? So what's the difference between the strings? The thing is that for strings, so for strings we can generate like a string literal, right? Literal basically, and we have a if we have a literal with this value, then we just return this value, right? This is not used, so we can remove that. Value flown into enum. Let's do that. Right. So there you go. In order to just generate support for strings in the language, we just basically we introduce two new things. In intermediate representation, we have the string literal, right? And we have a new value, which is a string. Now, all I do is I just say that for my final language, I'm combining not just numbers and lists, but also strings, right? And now I can do add my example, right? I can also push one more element to this list, which would be like, you know, hello world, right? Like this. Can I show the generated code? I guess I can. You know what? Let's do this. Let's do instead have make list, right? Where elements would be a vec of this. Let's do that instead. I think that's better. Instead of making nested pushes, let's make it simpler. So I will have a value where elements is elements iterate app select element, and over here we say k eval element context, something like that. Yeah, so for this example, we just say make list where elements is a vec of element 1 and element 2. And element 3. Let's do that. And then element 3 is a string, literal string value hello world. And I guess because I have the own string there. So this is the full example now. It's just make list 1, 2, 3, 1 plus 2, and hello world. So this is like a dynamically typed language where we can like store the different types in the same thing, right? Cargo run. How do I show the generated code? List items are eagerly evaluated expressions. Yeah. This is basically this over here. Make list is just similar to the vec macro in Rust, right? This is a macro which is like generating with capacity and then like pushes it. But we just instead like do this in the AST directly, because why not? Just to make it easier to do the example. Right, so this there we go, string. There we go. Now we have the string module, and now once again, string doesn't know about existence of numbers or lists. Numbers don't know about the existence of strings or lists. Lists don't know about numbers or strings, right? We just combine all of them together later. You wanted to see the generated code. How do I do this? Cargo expand. So cargo expand, this over here, right, is the important part. Module cast. So we have yeah, there we go. You see, we have like basically the instrument representation of this language is just, it's either a number, which is defined in the number module, or it's a list, which is defined in the list module, or it's a string, which is defined in the string module. This is a little bit too verbose, but that's just for like easier defining things. Sometimes don't worry about it too much. Yeah, and then similarly, if I want to evaluate the intermediate representation, I basically see if it's the intermediate representation from the number module, then we delegate it to the number module how exactly to evaluate this, right? Simple as that. It's yeah, really simple. And then we also generate these things of like for this type, we have trait has variant, which allows me to like convert from a variant to the full enum, and the other way around too. I think this is pretty simple. But I wanted to see this. So what if we wanted immediate use eludes me? What do you mean immediate use? Mender thrashed in. Hello. What is the immediate use? Are you talking about use superstar? Or you are talking about the fact that it's just being used immediately? It's just like the delegation. There's a name for this pattern, I'm pretty sure. Well, so anyway, what I wanted to say, what if, what's the objective besides the organization? This right now is being combined in the static Why and when will you use it? Well, yeah, so like the idea is to split the code of my programming language into parts, right? Because right now it's really difficult. It's all like it's difficult to split it. How to split it properly is something that is not an easy task, basically, right? But if you look at this right now, in this example, we have list, number, string modules, which are completely independent. You can think of these as like language extensions. So we start with an empty language, and then we extend it with a list, with number, with a string, and we get the combined language, which has all of these three things. So and then if we also have the ability to do this not only statically but dynamically, right, then maybe we will be able to write the language extensions in the language itself later, you know. But still, like, there is this trait which is specifying how what the module should be, right? So every module right now can introduce its own intermediate representation, its own type of values, its own like context for interpretation, although this one is always empty right now, so it doesn't matter. But yeah, I guess like also like for our language, since it's a type language, we would be able to generate our own types and maybe like some other things, you know. So like all the things that we want to be potentially extending here, and it is kind of checked. Doesn't look dynamic at all right now. Yeah, right now it's not dynamic at all. Right now it's all static. But the problem is that this in Rust cannot be a boxed-in trait anyway, right? Like, this cannot be treated as a dynamic object at all. Right? I cannot have a module as a value. I cannot have a type which implements this as a value at runtime, because associated types make it not like object safe, whatever, right? But I think this is a limitation of Rust. I think this is possible in languages like Haskell, because they implement it differently. Time to rewrite it in cast. Okay, wait, can you do this in Haskell, Nerdsel? And have this? So we were also writing this language first in OCaml, right? In OCaml, this is basically a module, right? So you have the modules in OCaml, and if you have a module with an argument, they just call it a functor. So in OCaml, you have them as functors, basically generic modules. But even in OCaml, there is this problem where you like these functors. They're not really treated as values. They only exist like at compile time. But in cast, we are treating everything as a value. It's a first-class language, right? So I potentially can make this work, maybe. I don't know. It's a rough idea for now. But yeah, basically, if we have we maybe could have like an extensible language, which is not only extending the syntax, right? Right now we only have the syntax that can be extended. But what if we could extend everything else? We could introduce our own things. Wouldn't the correct way to work in Rust, as you would in Rust, make a minimal cast interpreter, then bootstrap from there? No, I don't think I want a minimal implementation and then like rewrite it in cast. I think we will stick in with Rust for a long time. I don't like we can make a minimal language, rewrite the language in itself in the minimal language, but I don't like the idea, because working with minimal languages suck. If I don't have the features, then it's going to like be difficult to write the language in itself. So I want more features before I bootstrap itself, I think. Does that mean that you have like two representations of each things? No. No. I mean, potentially you can have two language extensions that like implement the same thing, but like, why would you do that, right? You should just not do that. Or what do you mean? Two representations of the same thing? So yeah, we are splitting the integer representation, and we're splitting the way we are like handling it, right? What if in this example, although we wanted to have strings to be edible, right? What if I want in this example have this? You know, what if I want to add a string literal hello, right? And I also want to add a string literal world. You know? What if I want to do this? This is not going to work, right? If I try cargo running this, it's going to say expected a number, because the because addition is only implemented for numbers, right? When I evaluate the left-hand side and right-hand side, they all must be a number. So this also needs to be like extensible or something. The reason I ask, because if everything is a value, then you need a runtime representation for it. But you also often need a compile time representation for many things like type. Yeah, I guess. Yeah. That's right. Yeah, that's right. There will be like, and it's not only like two representations for each thing, because I want to target not a single target but multiple targets at the same time potentially. So for every target there is its own representation of each thing, kind of. Yeah. And then yeah, so so the only target that I have right now is the interpreter, which is being used to run code at compile time, basically, right? And then like I have evaluated something at compile time using the interpreter, and then I want to put this into like the final binary as a compiled thing. Then I would need to convert the like representation of the interpreter into the representation of the like target that I'm compiling into. Yeah. So there would need to be functions specifying how to convert. Yeah. One representation. So like you can think about languages like Zig, for example, right? Zig also has comp time, but the way they do it is different. They so their interpreter is using the same representation basically as the target. So they only target one target basically at a time, right? When you're compiling things, and then all of the code at compile time is running, basically emulating the target. That's how they work in Zig. But this means that your compile time code can potentially behave differently depending on what you compile into. But on the plus side, it means that your compile time code works exactly the same way as your runtime code. While for cast, I don't I'm not trying to like have this. So like my compile time code and my runtime code can behave slightly differently. Like it's the responsibility of the implementer of the target, I guess, to make them be like similar. I'm not emulating the target. I'm instead running on it on a different target, which is the interpreter. They still have some internal representation duplicates. Maybe, I don't know. I don't know how it works. Yeah, so over here, right? What if I need this add to work with strings? How would I even do that? The comp time isn't target specific in itself, it's just the target is known at compile time. Yeah. Yes, exactly. But it's still like this comp time is trying to just emulate the target. The target is known at compile time, and so it knows how to emulate it at compile time, which means that the comp time is working differently depending on what thing you are targeting. The right switch targeting will only be verified for the current target. Yeah, because target is the constant at compile time. Yeah, that makes sense. So I'm trying to do it differently. Yes, for me, target is not a constant. A target is a variable instead. It's something like where my code, instead of just like having the code, it's just like the argument, right? So we have like argument target here, and then this code may be invoked with like multiple targets at the same time. If that makes any sense. But it's like a hidden argument, whatever. Yeah. I don't know a lot of languages that do that. The only language that does that is Nix, basically. The only language that I know that does the way that I want is Nix. So you can basically have like what I want is basically have a comp time function that compiles for one target, and then a comp time function that compiles for another target. So that at comp time, I'm targeting multiple targets, you know? If that makes sense. Yeah, all right. Anyway. This over here is something that I don't know. So over here, right, we panic because we expected a number. So how do I make this extensible, right? So that some other module can extend the behavior of this. That's something that I need to think about. But anyway, I was going to read this thing. Anyone seen this? The language that never was? So basically, some people like to play video games. Alright, now where do I even start? Games, yes, that's a good start. Some people like to play games, video games even, but video games don't grow on trees, you know? Yes, he wants Rust with GC, really? Look, mine is still fuzzy. I don't usually write in words. I could go all the way back to John Carmack, being an alleged asshole to the other John, sitting in the garage making Doom or something, don't ask me. Then something, fast forward, and there's John Blow influencing the next generation of wannabe C replacements while he sits comfortably in his private code club-driven development scheme working on that Sokoban game. And then there is an influential 10-year ago me watching those streams and thinking surely that what the world needs is another programming language for making video games. Except I thought so unironically, and I still kind of do, right? So like here we agree here. The world does need another programming language. But I don't think that a language for making video games and the language in general is just any different. Like, video games are not super specific in my opinion. That's where we disagree here. With both this person and John Blow, I guess. Wants to be liberated from the borrow checker. Was this only about the borrow checker? I don't know. I didn't read this fully. Why is this like 1,000 like pages? How long is this even? How long is this even? You know how many words are in this document? Hold on a second. Is this how we do it? It has 24,000 words. Is that a lot? I think that's a lot. That was some of the context nightly. Let's get started. What do I need in a game dev language? So like, this is why I think it's important. I think this person is talking about what we want from a language. Pretty well. I think I would agree here. Don't remember. I skimmed through this. Language design is a very opinionated thing, and game development is also a very opinionated thing. Everyone has different answers here, but I'd like to think my requirements lie somewhere on a reasonable middle ground and represent at least one another person. It is not unheard of that games need to run fast, despite the fact that nobody can agree on what that really means. Thankfully, as the old saying goes, computers are fast. Because as the other saying goes, picking Python or the wrong tool for the job will make computers go slow. It's not surprised that most discussions around language design for game development focus around performance. So to ease ourselves in on this journey, let's start there. The language needs to be fast, right? This is important. Okay, but how fast, right? How fast? Like maximum fastness? As far as I'm like, for example, for me, when I'm making my games, I don't care about performance at all. And for a lot of games, you don't care about performance at all, I think. Because the computers are fast enough. No? I mean, I like over here, picking Python is the wrong tool for the job, yes. I started with Python, and then the reason I went away from Python was because of the performance. Yeah, that's true. But then basically any other language is fast enough. Maybe even Python these days. Isn't Python like 20 times faster than it was 20 years ago? You don't care about performance. I totally hit a performance issue. Yeah. I guess so. But it's usually not about the language. It's about an algorithm. I think most of the time. Python works for everything, always the wrong choice. As far as I'm concerned, there's one key property in languages that separate languages that can do this. Okay, do this, do what? From those that don't. I mean, Python can do that, the video, pretty sure. And it's not discussed often enough. Oh, it's value types. By value types, I mean the language must have a notion of a struct, where the language guarantees that what you see is what you get. If I declare a value type with 32-bit floats, then the in-memory representation for the struct can contain is exactly 12 bytes. I think this is wrong here. I think this doesn't matter. I think the in-memory representation is the implementation detail that you shouldn't care about. That's why there are things like paddings and stuff, right? Which people have extensive discussion on that on Reddit. And there is a synopsis there. I won't read this fully, I think, but the first section where, like, chapter 1, like, what do we need in a programming language? Because I'm making a programming language, right? So as is cast, is my programming language going to be fast? Right? Well, I mean, I have this idea of making it fast. I'm not making it a first priority, though. This is not the most important thing for me. But the idea is to have enough information in the type system so that we can compile it to efficient code. But this over here, like, why do you even care about the in-memory representation? That's an implementation detail, right? Arranged in the obvious way. Like, why do you need this? It does, and it's not like it's not like that even in C, right? If you define a type with like a 32-bit integer and then like a boolean and then another 32-bit integer, there's going to be a gap, right, in between the boolean and the second integer, right? So this is basically not true for any language. The thing goes on the stack, whatever stack means. Value types stay on the stack. Allocating them is as close as bumping the stack pointer it can get. Passing them to functions should be as close as a few move instructions it can get. Returning them from functions. Well, that triggers painful memories from the system v ABI. What's system v? I don't know. Array of structs are packed together. Games usually don't want to have a lot of thing. A thing can be... games usually want to have a lot of thing. The thing can be particle, enemy, tile, or whatever your imagination allows. Having a lot of things, meaning having to process a lot of things fast. So we want cache locality. If things are stored sequentially in memory and iterated sequentially, things are fast because we live in the bed timeline where RAM is slow. And ALU. What is ALU? I don't know. I don't do low level stuff too much. Arithmetic logic unit. Aluminum, chemical element, are fast, and SSE is even faster, and linked lists are slow. Yeah, linked lists. Yes. Because the Lisp machine never took off or something. The thing is, if I put value types in an array, it better look like their bytes are stored in line and sequentially. You better not give me a list of pointers, each pointing to data scattered throughout the heap. You hear me? I think this over here is a good point. I think this is the reason I never got into Haskell for programming, because I mean no, that's no. Like, it's not, that's not the reason. But yeah. Haskell really not about this and for this. What do you mean for this? For game development? Should not get into Haskell anyway. It's 2025. Get into Coq. Yeah, right. I was actually wanting to try either Coq or I don't know. Did you so you know Coq, right? And there's also the Agda. Agda versus Coq. Which one is better? Versus Idris. Well, I mean, Idris, I guess, is Agda is Haskell-like syntax, very powerful mixed fixed notation, compiles to Haskell or JavaScript with a very nice FFI. Coq is OCaml-like recursive notation, experts in large variety of languages. Idris Haskell-like CFFI. has the most out of the three. So Coq is the most used language, I guess, right? Out of these three. So maybe I should try Coq instead of Agda. There was like a couple features in those languages that I wanted to look at. There is a thing which is called size types, I think. Sized types. I wanted to know about this. Size helps the termination checker by tracking the depth of data structure across definition boundaries. It's like decidable language can be represented as infinite trees. It's like to know that that your code is going to terminate, right? Termination checker. Like, is your code going to run forever, or is it actually going to finish at some point? Something. That's all that I know. Am I reading that blog? This one? Because it talks about what people want from a programming language. Right? So here's the first point. It's going to be fast. And I think these points, I think this is in alignment with what Cast is going to be. Basically, right? It's just that right now we only have the interpreter, but we're going to compile, and this is going to be true. Most languages offer a limited support of this, except for the pathologically dynamic cases. I'm not going to take another step at the snake. We all know who we're talking about. An int is an int. Ints aren't boxed, and thus follow most of these properties. But the point is to allow custom user-defined value types. That's what allows us to climb up the ladder of abstraction without losing performance. Primitives being value types is not enough. Yeah, I guess I can agree with that. And note how I didn't mention a property of a value types that some consider essential: immutability. No. Yes. I don't think that it's essential. Actually, if anything, I prefer my value types to be very mutable. Immutable, as mutable as I can get away with. Well, yeah, and games are big mutation machines in that sense. I lost my faith in Project Valhalla. The Mojang, I realized after all these years they were only going for immutable value types. What's the Project Valhalla? Project Valhalla wants to heal the rift in Java's type system between classes and primitive types that were introduced in the value types. I see. Any language that mentions Brzozowski derivative int in the docs is a hard no for me. Wait, what is this? And what language has that in the docs? Brzozowski derivative is a set of strings and a string u of a set S of strings, and a string u is the set of all strings obtainable from a string in S by cutting off the prefix u. Formally, this, where uv belongs to S. I see. All right. So C, yeah. Okay. What is that useful for? You just saw it while I was browsing the docs of Coq. Well, Coq is the proof assistant. It's not like a real programming language, I guess. You don't write programs in it, you use it to prove things, right? I don't know if it's used to write actual programs. I mean, you can, but like, do you? Do you write real programs in that? Is there a game engine in Coq? chip 8 emulator in Coq. Fully functional chip 8 emulator written in purely Coq. A single file. Because what you write in Coq is not too complicated in terms of programming, because every program is a proof. And we struggle with creating very complex proofs. Yeah. Since Tajaf. Sinestajaf. Hello, hello. Alright, anyway, so they were only going for immutable value types because they couldn't figure out how to make mutability works. That's is sad. Yeah, we do want mutability for sure. I agree with that. But let's see what they talk about the borrow checker here. Lots of the sorry. A lot of young fursuit wearers are spending their bandwidth thonking intensely about some flavor of automatic memory management, more often than not involving checks and borrows. What is this even? What language are they using here? To me, it's an interesting and valid question to tackle, but ultimately the wrong angle for a game development language. Wait, what? Spending bandwidth, thonking intensely about some flavor of automatic memory management, more often than not involving checks and borrows. But then the borrow checker is involving checks and borrows, right? It checks the borrows, right? So this is the right angle about the game development, is it? I'm more interested in having the properties I discussed above than anything to do with ownership, RAI, or lifetimes. I do vote for having pure functions though. So what is a pure function though? I think cast can be treated as a pure function, as a pure language where the functions are pure, but the purity is not the same as like those functional programming languages. Purity means that you can only reach something that is declared in the function arguments or contexts, where contexts are basically like the implicit arguments in cast. So like you cannot just do something that you are not allowed to. You are not allowed to access global state and mutate it unless you have defined it as your function argument. So like you can only have access to the things that you have been given access to. So it's not a pure function does not mean no side effects. It means that you like in cast you can have the effects, but effects they need to be documented. They are not like you cannot have unobservable side effects, right? If you have a side effect, language needs to know about it, right? That's what monads are. Yes. Yes. Monads is another way to do the same thing. Yeah. I just think that the effect system is better than the monad system. The way I see it, it's not that hard to take whatever system your language offers and makes it perform well, be it garbage collector, reference counting, generation references, or the infamous borrow checker. If you want it to be fast, you will pre-allocate, reuse memory, and avoid allocations in your hot loop. If you want to be fast, you will pre-allocate, reuse memory, and avoid allocations in your hot loop. And that's just as true for C and Rust as it is for any flavored GC language. All right, so now what? You still want the borrow checker to be there? No? And speaking of things, people like and like I don't do this. I don't use the arena allocators at all. I wonder how much faster is like Linksider going to be if I just do this. You know, just make sure that all the memory that I'm allocating every frame is being allocated with like an arena allocator instead. You still need to show me what context are not going to be a leaky abstraction. What do you mean a leaky abstraction? Context is just an implicit argument, so you can think of them as just arguments. But then we have control flow in the form of a value which is like different from your normal function programming languages. But I guess it's like not super different. You can think about the control flow as just returning a separate value from a function, I guess, right? Like if you throw an exception, you can just you can always like just rewrite this code as the function that just returns a result. It's kind of the same thing, right? Allocator in context is probably sufficient and simpler than borrow checking program-wide. Could context be considered a new form of function coloring? Yes, but we have like a lot of colors in the functions. So it's just nothing. It's not like the big problem. I think the problem with coloring in Rust and like in most programming languages, when you have like a function foo and like it does something, right? And then inside function like main whatever, right, you just call this function foo, right? That's how you call it. But then if you make this async, then this no longer works, right? If you want the same effect, then you would need to now await it, right? So that's like I guess one of the core differences between like Rust and Cast. This is no longer going to be needed, and it's just going to work the same way. The async needs to just be handled at some point. Similar to like exceptions in Rust, if you have a function that returns a result, right, then you need to have a question mark, right? But in Cast this would be like propagate automatically. So this is also a form of like coloring, right? Whether a function returns the result or just a normal like type. With effects that you need to specify it in one place instead of two. Well, it's not just two, right? Without like in Rust with async, you need to do dot await everywhere. You call an async function, right? But in Cast, you would only need to have this in two places. In the function, like in the final function, I guess, which like uses well, I guess throwing an exception is a better example, right? So you have like a function foo that like throws an exception, kind of. Otherwise it returns like some t, right? So you do this here, and then you also need to have this in some other place where you create the exception handler. I guess those are the two places. And in all the middle cases, this is going to be just inferred. The thing. So yeah, I guess even this is going to be inferred, right? So the only place is just having this like throw keyword, right? This means that all of the functions in the chain are going to be annotated with the throws effect, and then at some point you have a handler. And in terms of async, you instead of a handler, you just have the creation of the async runtime. Maybe you should I don't know how to explain these things to someone who didn't try or didn't read about other programming languages with effect systems, right? And like basically it's not in any mainstream language, so no one knows about this. If you change a function all the way down the stack, that could affect the color all the way up the stack, action at a distance. Yeah. Well, you can always guarantee that a certain like color doesn't get. So like yes, it needs to be handled somewhere. Yes. What do you mean leaky though? If you change a function down the call stack, that would affect the color way up the stack. Yes, but I mean, like if you panic somewhere inside your inner code and your previous code, if previously you had all the code which was assuming that a panic is never happening, and now somewhere deep inside, you have a function that now starts panicking, then you need to do something about it, right? If you didn't have a handler for panic, now you will need to insert that handler somewhere, right? It doesn't matter where exactly you have it, but you need to have it somewhere. If you introduced an async code somewhere deep in the code, then you need to handle the async somewhere. I'm more worried about the other way around. You have a system for panics, but now you removed downstack. So you say that you had code that was handling panics, but now no one is actually panicking. Is that the problem? So I mean, you what you want is to delete the handler of panics. Like, how is that a problem? Yeah, I don't know. Like, I guess it's kind of a problem because you have a handler for panics, but panics never actually happen. So you have like this dead code kind of, right? You are trying to catch an exception that is never thrown. I think this is more like a warning than like we can have a lint for that, right? Like, this code never panics, but you're catching panics. Why are you doing that? That wouldn't cause a compiler error? Like, why should it cause a compiler error? I don't think it should. Basically, when you are saying that you have, if you have a system for panic, if you're handling panics, it means that the code inside can panic. If it doesn't actually panic, that's totally fine, right? It's like when you are introducing a handler for a panic, it means that you're allowing the code inside to panic. But it doesn't necessarily panic. Yeah. You are basically giving permission to the code to panic explicitly when you have a system for panics. That's what's happening. The typing is wrong, isn't it? Or effect typing? I'm not sure. Never worked with effect. So yeah, basically, I guess we have like subtyping for this. So if you have a function, of type, you know, like, I don't know, something with panic, right? A function that can panic, right? Then and then you have a function that doesn't panic, like this, right? It just doesn't do anything. Then you can treat this function as a function that can panic, kind of, because this is because this over here, no, this over here is a subtype of this type. All right, it's a subtype. It's similar. No, I guess we don't have this. I guess the only subtyping in Rust is the the only subtyping in Rust is with the lifetimes, so there is no like direct analogy there. But I guess like this only works if this only works for things that like may happen or may not happen. I can see the need to have like effects that must happen, or the effects that must happen exactly once, which would be the language would need to have linear types, or linear types, or relevance types, I guess, for something that needs to happen at least once, and then this would not be a subtype, you know. Like for example, you want to pass, I don't know, like we don't have linear types in Rust too, so like I mean an example is also difficult. In Rust we have the affine types, which are types that can be used at most once, right? So I guess this also can be done. We can only panic at most once inside these functions, right? But this function panics no times, so it's still is working. Yeah, and like traits are sort of subtyping, kind of. Yeah. So like it's not like implemented. It does not necessarily. This does not necessarily needs to be implemented as a subtyping. They're in, as far as I understand, like most of the languages with effect system, they work with the role polymorphism instead, which is kind of similar to subtyping too, right? And then there is also this new idea, by the way, which I don't exactly sure. There's this paper which is called model effect types. So basically with role polymorphism, instead of saying that this is a function that returns nothing, right, you actually say that this is a function that so like instead of saying what a function can do, we say what a function can work with, right? What sort of handlers we have in scope, basically what can be handled by the context, right? So we say that this can work with any context. So like for all contexts, this is the type, right? And the function that like we know that can panic, it's basically it can panic and do some other things, right? This is like basically role polymorphism. So we know that we have a field panic basically in the struct representing the effects, and we can have some other like rows, some other fields there. But this complicates the signature a little bit. So in this paper, they say that we can do just this, but it works a little bit differently. It's not exactly like subtyping. Something. I don't know. I don't understand exactly what they're doing here and what is exactly the model. There is a thing that's called the model type theory. Anyone knows about that? Commander Thrashdin? Do you know what a model type is? You know a lot, right? You know model types. So yeah, like remember when I was like making the inference for the effects for the context system in Cast, and then I was looking into subtyping because I thought we would need subtyping. Then I started reading about how other languages actually implement this. So like Coca implements it not with subtyping but with role polymorphism, and like other languages too. And then this over here, the model type effects, is like the new stuff. This is literally from 2025, which is like the new approach, which is allowing for like simpler signatures, something. Can you explain minicast? I was explaining it earlier, but yeah, you know, let's just read a little bit more. Maybe I can return to the minicast later. Can you give a link to the model types? Well, this is specifically model effect types. This is not the model type theory. There is a thing that is called the model type theory, right? Or I guess multi-model type theory. Multi-model type theory. Multimodal dependent type theory, right? So we know what is dependent types, but then there's like the multimodal dependent types or whatever. I don't know. Dependent type theory which supports multiple modalities, okay? What if you go the other way and treat polymorphic generics as supertype? Well, supertype is just the opposite of the subtype. If you have supertypes, then you have subtypes too, right? Model types allow the type system to reason about scope in a very general sense, whatever that means. I don't know. I don't like exactly understand them. Model types allow the system to reason about scope in a very general sense, so potential applications are very broad and not thoroughly understood yet. It's an active area of research. Potential applications include stage metaprogramming, distributed programming, memory management, first-class control, algebraic effects. So the effects is just like one of the things to do that. And then and like for memory management, I guess like you use the model types to do like linear types and like other things to something. I'm not exactly sure what it is. All right, let's see. So the language needs to be fast, all right? The language needs to be fast. T is a supertype of I32, I16, I8. All of those are subtypes, allowing you to define a named integer type. Likewise for unsigned. Yeah. It's not a supertype. I mean, so like, this is where like subtyping and traits is very similar, right? So instead of saying that your function should take as an argument the argument of like, which is called like an integer type, right? Instead of saying this, integer is a trait, and you accept the argument of type t, which is an integer, right? Which implements the integer type. And unsigned is a trait. An integer is a trait, right? So yes, but yes, if you are doing an object-oriented language, which is like Java, then you can have the int32 to be implementing the interface integer, and then it would be just subtyping, right? You just accept the value of the type, which is the interface, right? Which is kind of like basically like the din trait. Yeah, I actually it is the din trait. Wait, we have subtyping in Rust in the form of din traits, yes, right? So so a type T is basically always a subtype of a din trait, where trait is implemented. Yeah. So it's not only about the yeah. So in Rust we have subtyping for lifetimes. We have lifetimes. We have din trait, and we also have the never type. By the way, never type is also having the subtype relationship because every type is a subtype of the never type. Rust subtyping. Yeah. Closures too. Closures. Well, I mean, closures are done with the dnfn trait, but I guess there is also the implicit coercion to like the function types, right? Like from a closure can be treated as a function, and like also like every concrete function has its own dedicated type, but it can also be like treated as like a function pointer, basically, right? There's function types in Rust. So the functions can work with like dnfn traits, or they can work with just like native functions. Right? You can have function main, and you can have f, which is a function like this, which is a closure like that, right? So even although this closure has a concrete type of its own closure, it can be coerced into a function pointer like this, right? Because it doesn't actually capture any variables, right? But if I say x be 0, and over here we say print x, then this no longer works because we now capture the environment, so it cannot. Yeah, we expect the function pointer, but we found the closure. Closures can only be coerced to function type if they do not capture the variables. I guess this is another. Is there anything else? No. All right. Anyway, we have to go fast. We need to have mutability. We want to have user-defined value types. Something is the wrong for game development. So they're not interested in ownership, RAI, or lifetimes, which is weird. I think RAI is very useful in game development. Ownership is just in general very useful. And lifetimes is always there where we have the ownership. Beat garbage collector, reference counting, generation references. If you want to be fast, you will pre-allocate. Yeah, sure. And speaking of things people don't often care about, there is another thing. I wish language designers spent more thonking cycles. One that is also essential for game development, it's metaprogramming. Okay. Metaprogramming is important, yes. We want compile time evaluation too, and compile time code generation. Metaprogramming, interesting concept. Games are huge beasts. They are a long way from the do one thing and do it well style of programs other people may used to. Games are user interfaces, world simulation. Yeah, that's why I'm saying like game development is actually like the perfect candidate for like the like if you make a language for game development, it just basically means that you have a language for everything. Gives you a lot of things, most of them poorly. This is why the average game code base is scattered with all sorts of interrelated systems that all need to run, sometimes caring about each other, sometimes not. Games are visual craft. You cannot do everything in code. More often than not, you need to look at things, tweak things in an editor. Well, gizmos everywhere. Gizmos is where it's at. You forgot about Veil. I wonder if it can be used for Minecraft. Is there a way to make closure recursion possible? Coercing to a function pointer? In Rust, you cannot have closures that are recursive, no. But in Cast, yes. I do want to do that. And then it should be, I guess... I'm not sure about the function pointers, though. Well, I mean, I guess I do. Yeah. So in Cast, everything is a closure, basically, right? But all the functions are closures. So I need to have recursive closures to have recursive functions. So I guess the difference is not that it's like capturing, like I'm always capturing the environment, but some of that environment is like only existing at comp time, which means that it doesn't need the context actually, I guess. Yeah, no, I can detect it, yeah. And so that, like, if it needs a, if it is correspondable to just a function pointer or not. All right, anyway, but I digress. What I mean to say by all this is that there are two paths to achieve all those things I'm mentioning. Power through it via a large amount of boilerplate to, or embrace metaprogramming. That is automating that boilerplate. You don't have to type it. I've seen people be successful in boilerplate embracing scenarios, good for them. But I choose the later out of necessity. Metaprogramming can mean many things. However, let me take a moment to clarify what things I'm interested in. Reflection at compile time. Something not many languages do is letting me take a peek at the data structures they use for compilation. Code is data, not a bunch of lists. Don't keep the data to yourself, don't make excuses. Being able to look at the shape of things in code is the bread and butter of building game editors, serialization of game state, and also to minimize boilerplate in all sorts of give me all the X that can do Y situations in codebase. For example, give me all game systems in the codebase that so I can call them in a loop. Or give me all classes that implement the auto-tiler interface so I can register them automatically in this widget. These are real examples. The developers have been demanding your respect for all this time. The alternative to this is fragile boilerplate and non-local code base, where adding one new thing requires registering the thing in 5 different files in non-obvious ways, with most related errors relegated to runtime. If your language has you spending more time writing guides to enroll new developer on how to add new acts instead of writing other programs to do for you, maybe things could be done a bit better. So reflection at compile time. I do agree this is very good to have reflection at compile time. Rust does not have that. Custom metadata, but compile time reflection is not the whole. It's not whole without a way for me to sprinkle my own little annotations on top of things. Yeah, sure. Yeah, we need to have annotations in cast. I agree with that. So that that are not used by the compiler but used in metaprogramming for sure. Can you do annotations in Zig? Wait a second. Zig field annotations. Proposal, code annotations. Proposal is to introduce code annotations. These are a special type of comment that, like doc comments, are tied to a specific piece of code. These kind of hints are third-party tooling to do things such as auto-generate surrounding code or to do static analysis. HTTP server get, yeah, so that we can like generate code based on that, right? That's what we want. Does Zig have that? Or did they like say that it's it makes the language more difficult or something? Closed as not planned. Closing in favor of this. Tags. Closed as not planned. You hate annotations? It allows the property pattern, which is a Python food gun. Well, Python annotations are basically same as like proc macros. It's not just an annotation, right? To the thing. It's actually converting the code into some other code, right? That's what you're talking about. The type of annotations that we want is like when you work with SERD in Rust, right? You can annotate the field with an attribute which says that like this should actually in JSON be serialized as like this name, right? Or I don't know, skip serializing if some condition, right? You want to have these annotations that don't actually like compile to anything, but they are used when like doing code generation. Call them attributes for a good distinction instead of annotation. Sure. So they closed this. Is not planned. Is there like a way like similar to Serde in Zig to customize the serialization though? Attribute. The SPIR-V backend would benefit from this proposal so it can overcome the problems described in these. Add SPIR-V type built in. Yeah, we want to have attributes like this. Call them cast tribute. No one knows Zig. Type attributes in Zig would be very useful. When was it closed? Rejected to retain language simplicity. Of course. Of course. The real-world use cases, serialization, deserialization, already have been explored and found to be satisfactory with the status quo language. So how do they do that? How do they do that if I want my struct be serialized and rename a field? What's the alternative for Serde rename new name in Zig? Would you just do manual serialization? That's annoying. Using serialization library that supports renaming. For example, ZJSON, you might define a custom serialization function for struct. Okay, I guess like with mapping structs, you can do that. So you're like, instead of serializing your structs directly, you create a new struct and then serialize that. But isn't that like having overhead? ZJSON. Deprecated. CLJSON. Oh, that's something else. That's like common Lisp. Huh? You don't know how they did it, but I'll bet on external code generation. Well, I mean, this makes sense, right? You just can create a new struct with just serialized as is, which does not need any annotations. There are some experimental efforts for macros and metaprogramming in Zig, like using field type info. But there is no annotation system like Rust attributes just yet. But I mean, there will not be, right? Because they said for language simplicity. Okay, but I'm pretty sure that it's important to have attributes, custom metadata on your type. So like when you are inspecting things at compile time, you want to be able to inspect not only the things that compiler understands, but also some things that only the only you understand. So you want to annotate things with things that compiler doesn't know. Custom metadata, custom attributes. I do agree with that. For code locality reasons, it is important that I can define any scheduling constraints for a system at the location that the system is defined, not in a different file, and ensure hope not in some YAML file. scheduling constraints of a system. So scheduling constraint of a system is like if we are writing in Bevy, you can say that the system should run after or before some other thing, right? So imagine, like, yeah. So like in Bevy, you are adding a system inside like the like plugin initialization code, and then this is the code where you define these constraints, right? Instead of having on the function itself like the metadata that this function should run before or after some other system, right? That's what they want. I think that makes sense, actually. And also, like, just over here, they said that they want to give me all systems that that exist, right? So basically, you annotate all of your systems with some like attribute, and then instead of listing them explicitly in some code to like register the systems, you just say like register them all. Register all the things that are annotated in my crate. Yeah, maybe. It's kind of similar. This can be kind of solved in Rust with the inventory crate, I think. You guys know about this? Type distributed plugin registration. This crate provides a way to set up a plugin registry into plugins that can be registered from any source file linked into your application. So yeah, basically, you have example. Suppose we're writing a command line flags library and we want to allow any source file to register command line flags that are relevant to it. So we add a flag to the inventory. Now any crate with access to the flag type can register flags as plugin. Plugin can be registered by the same crate that declares the plugin type. And then we can iterate over all of the flags. Yeah. Yeah. So like basically we have a, like we could have a struct system, and like this is like a system in Bevy, and we collect all of the systems. So then all of the things that are introduced in the system, they would submit to the inventory a new system, and we can just iterate over all the systems. So that's how it can work in Rust, I guess. This thing. It's not exactly reflection at compile time though, because this is working at runtime, not at compile time. So what they want is to do this, but at compile time. And I mean, I kind of like this idea, yes. Reflection at runtime. At the hot loops, the game can be very static, but in its many... Oh wait, code generation. The two previous points gave us eyes into the code base, so you can like inspect the metabase, the code base. But now we want to be able to generate code. There's plenty of ways to do it, but let's be honest, if you are an AskExpression-based language, give me lists. Otherwise, just hand me a good string interpolation, and I'll be reasonably happy. Please don't try get too clever and waste everyone's compile time. They are linking to the Rust quote crate here, saying don't try to be too clever. String interpolation. What do you mean, give me lists? We tried stream implementation, see it's bad. Yeah, like why don't they like the quote crate in Rust though? And waste everyone's compile time. Well, I mean, this is not a language. Like this thing in Rust is not implemented at the language level, right? Like unlike in Lisp, the macros, they basically are implemented in the language, and in Cast we have the macros which are implemented in the language. We can generate code. I can generate the ASTs, which is kind of similar to like interpolation, but it's called AST interpolation, not string interpolation. So I generate the AST using interpolation, and that's how I generate code. The only difference with Rust is that it's not a library, but a built-in. Rust macros are very bad. Well, it's because they're a different language. What exactly? Why exactly do you think they're bad? So like in Rust, you get like the scene crate. So that way you get the AST, and they have the quote crate. You have no access to enclosing scope. You have to parse the code. I think there is a proposal for that. I'm not sure. So, I mean, there is, at least like when you're writing a proc macro, you can generate, you can like specify the hygiene of the identifier, whether it's referring to the identifier in the enclosing scope, or is it like a macro specific thing, right? It's called hygiene. But in Rust, like if you're talking about the declarative macros, then declarative macros, they are always hygienic in Rust, which is why you can have no access to the enclosing scope. Yes. Actually, like it's not exactly like that. Hold on. Rust macro hygiene. It's a mixed thing. I'm pretty sure macros in Rust are partially hygienic. Specifically, they're hygienic when it comes to most identifiers, but not when it comes to generic type parameters or lifetimes. So like it's a 50-50. Some things you can have the enclosing scope. Let's have a, let's see, do they have the example here? They don't have very good examples. So you can have function foo, which is like generic, you know, over t, which is like, I don't know, default, for example, right? And this should return this should just return t, so t default, right? You can do this. This works. It's foo i32. Let's say like this, right? So this works, and then you can have a macro rules t default, which would be just nothing into t default. So you see how I'm using this t here, which is actually is only available in this scope, right? This is supposed to compile still, right? It does. So this is not hygienic, but this does not work for the variables, right? Like I cannot say here dbg x, for example, right? This will complain that x is not found in this scope. Wait, do I need like parentheses here? I think. No, I need this. There we go. Yeah, there we go. So it says can find variable x in this scope, right? So it can find variable t, but it cannot find x, which is weird. Regilis Pires Stibilentors. That's a very difficult name for me to read. Hello. So yeah, like it's weird in Rust. It's partially hygienic. But with proc macros, you can define for every symbol that you're generating if it is supposed to be the definition side or like mixed sides, right? So when you have the where is it in sin, right? You have this thing called it's based on spans, right? So you have span. Or where is it? It's in proc macro too, right? Span, and you can say call site or mixed site. So when you are generating an identifier, over here, right? This is basically the identifier in the generated code, right? Since this is inside the macro rules in the declarative macro, this is automatically the mixed site. But if you do the call site when you're implementing this as a proc macro, then you can actually refer to X from this over here. I guess I cannot show this on the playground, but you can make this code work by making this to have the call site. Identifiers created with this span will be resolved as if they were written directly at the macro call location. So like you have access to the enclosing scope in that way. You just need to write a proc macro instead of a declarative one. But I think there was a way to Rust declarative macro hygiene, like wasn't there like an RFC or something? There's also like Rust macros 2.0. Is this going to be stabilized anytime soon, by the way? Pattern hygiene. I don't know if they talked about this here. I think you need to have a proc macro for customizing the hygiene. Anyway. Anyway, code generation, I don't know. I feel like the way it's working in Cast already is like the good way to do it. I don't know how better to do it. We basically have in Cast a function that can be so like we have compile time evaluation, right? And and we can generate code. Like for example here, right? We have a loop which is just implemented as a macro. I'm generating this code by just having a function that takes a body. This has the type AST, and then I'm returning a new AST, right? With basically constructing the AST and using the interpolation. So the interpolation over here with a $sign body is just being injected over here, right? Inside all of this code. And then we can also have some custom logic too. This is just returning the AST directly with interpolation, but we can have like we can have arbitrary logic before returning the quote. So this is like a proc macro in Rust, but it doesn't need a separate crate or anything. It's like a Lisp macro, not string interpolation. Yeah, it's like a Lisp macro basically, yes. So Lisp macros are also the same thing. Lisp macros are just functions that are just evaluated as like while the code is being parsed, right? That's how it works in Rust, in Lisp. So we literally have the same thing. You can have, and you can also have any Here's how we could define the set Q2 macro. Quote. Why is there no quote though if this is a macro? Hold on. It's been a while. Oh, we also use the quote. What am I blind? I don't see the quote here. Def macro. Dev Ninja, hello. Hello, my name is Ijuk. Another question. Do you know if it's possible to buy Android TV box devices online somewhere? Android TV box device? I don't know what it is. No. I cannot help, sorry. I don't have a TV. And not Android TV. I do have Android though, but you can buy an Android phone anywhere. I mean, you know where to buy them, right? Did you try Googling? In list, you can either build the code as list or use quasi quotes, which is just a shorthand to build list. Oh, so like list is hold on, like it takes as a parameter 2 variables and 1 expression. So like 2 variables and 1 expression. This is the arguments to the macro, right? And then it returns a piece of code. At least because code is represented a list, we can simply return a list that represents the code. Yes, so like list with these 3 elements, right? Prog n, whatever that is. Like, oh, or is this like an operator? I thought this is just its own like symbol, but it's not defined anywhere. But we want to do we want to basically to return this code, right? Prog n, right? And then set q v1e. So yeah. I guess list. I guess I just don't know how list works, right? So list goes over its arguments, and if the argument is an identifier starting with like the quote, then it just puts this as is. Otherwise, it's trying to like get the value of the variable. I guess that's what it means, right? Yeah. And then you can just quote. No? Quote, the special operator. Yeah, so this is the special operator, quote. Yeah. Quote is just a quote is a shortcut for quote. Quote foo and foo are equivalent. Both evaluate just foo. Yeah. And then they have quote and unquote. No. Yeah. There we go. So you have quote, and then inside the quote you do this. But this quotes it directly. So we want to the unquote. I think unquote is like a comma, right? Somewhere. A comma splice, the comma. So you quote and then you unquote the thing. Anyway, yeah, it's working the same way. I'm pretty sure. So yeah, we have the quote operator and the unquote operator, which is basically the interpolation inside the quote. And I think this is the best way that people have figured out so far, right? But we like we should still be able to like parse a string too. But this is just not the preferred way of doing it. I think we should have like a function that just takes a string and tries to parse it too, because why not? Did I ever try Crystal? No, I did not. Crystal Lang. What was it about it? Require HTTP server. Is this Go? A language for humans and computers. Statically typed and type errors are caught orally by the compiler, managing the range of type-related errors at runtime. Type annotations are rarely necessary thanks to the powerful type inference. This keeps the code clean and feels like a dynamic language. Nil values are represented by a special type nil, and any value that can be nil as a union type, including nil. Syntax is inspired by Ruby's. Green threads. Allows to define C bindings. And also, Metaprogress is part of a macro system which ranges from basic templating and AST inspection to types inspection and running arbitrary external programs. Yeah, I guess like this is the same. The person has instance var name. Is type instant var is map and name stringify includes name. Is this like a macro? Because it's a question mark. Shards. Libraries are packed with shards. A distributed dependency manager without a centralized repository. Produces dependency in shard YAML and fetches the source code from their repositories. Type inspection though, how late in the completion process do those macros run? Yeah, I guess like if you, yeah, so they are run immediately, just like in Lisp, so we don't have, yeah, you're right. So we want to be able to generate code based on the type inspection. So we have a limitation like that, yes. Did they say or that they have over here type inspection? Type includes name. I'm not sure what about this syntax, but like I do agree that like if we want to be able to write a macro, right? Let's say play cast language, right? So I can have a macro which is a macro taking something, right? Somebody returning let's see, dbg. Wait, can I even do this? A macro inside a quote inside a quote? I'm not sure if I can do this right now. Macro hello world. Yeah, there we go. So this is just taking this AST and just debug prints the AST itself, right? So this hello world is just a tuple with two fields where field A is hello and field B is world, right? Yeah. But we want to have type inspection, right? So let's say that this has some type, right? Like an int32 here. I want to debug body, right? We know that this is a type int32, right? But I want to have some conditions here. So before returning the quote, I want to be able to, before doing this, but this is the AST, right? This is AST. I do not have the type information here. Yes. And I should be able to have the type information here, right? So I want to, like, how do I do this? I want to basically But since this is AST, well, like, what's the meaning of this AST? I just need to evaluate this, right? Which is just, let's see, compile AST, right? I have this compile AST. So I just have compile AST body, and this is the type, dbg type. Let's see if this works. Function is not compiled yet. But I think maybe I need to say that this is AST. No. Let me try this in my example type inspect. This should be possible, right? Something like this. Cargo just examples type inspect. Binding body is not AST. Oh, binding body is not AST. Yeah, that's right. Because compile AST, yeah, I cannot compile it right now, right? Because I'm inside the function. The body is not known yet. The body will know when I run the macro, right? Jumblo had something about that in Jai type inspection, but not well informed. That'd be interesting to check. Hold on, like, how do I do this, right? I want to basically generate different code based on the type that I pass to the macro, right? Something. So like, I want to treat this as a type. So I want to compile this in runtime of this macro, right? But to compile AST right now is just trying to do this at compile time, which is not what I want. Because at compile time of this macro is is before we run the macro, right? Before we expand it. So I want something similar to this, which is wait, do I have eval AST or something? Eval AST. Maybe I should have an eval AST. Because this is like at runtime, I want to invoke more compilation, right? Like, I want to eval AST. This is just a function taking the AST and returning what? So I want to evaluate this as a type, right? So we would know that this AST needs to be compiled into something that returns a type. And we just do this at runtime, I think. A more interesting challenge, you receive a symbol as the body, say X, and you want in your macro to act depending on its type. Yeah, but I think like I just need the type of operator, and I think this will solve it automatically. So I would evaluate AST, which is like type of body, like this, you know. Type of is very easy to implement. I had it in my previous OCaml implementation. I just never got to it in my ROS 3, right? So I think this is all the thing that I'm missing right now. Evaluate AST body, and then I say that something like if type is equal to an int32, then you know, I just then I return print had an int, right? Otherwise I return print not an int, right? That's the code that we generate. So this is going to be basically replaced with this code if this was int32 or not. And this is like already a value. This is not comparing the AST, it's comparing the actual type. And then we could have like more type inspection, I guess, which I don't have the APIs for. Let me try this real quickly to implement the eval AST. I think this should be easy. I think. Or is it? I don't know. But would you already have that info, the type of X, when the macro is run? You wouldn't know that by just interpreting X, the start of the calling function. The function should be already typed. Yeah. So I think that so we have evaluation being async, and I can wait for things to be available, which means that but yeah, since this is a generating the code, it would need to like be already typed. Yes. Like because like the code that is generating here can potentially affect the typing of a symbol, right? Jai has such delaying tactics too. Yeah, so right now I only have the delaying tactics for the function bodies. So whenever I see this function over here, I basically compile this asynchronously, right? So that like over here, the body has the type AST, right? But this can be inferred not only based on the body of the function, but also based on the usage of the function. And since this is a macro, we know that it must be an AST, the argument to it. But we can have like more async stuff. Mostly it's basically right now pausing the compilation. If I am trying to see the symbol, which is defined later, and not for the types, but we can have it for the types too, right? Yeah, basically if I want to have like recursive scope where I have the function f, which is calling function g, right? And then function g is something, right? Obviously the g here is not known when I'm compiling this code, right? So in order to know what g is, I need to wait for it to be defined. So I compile this body in a separate async task, which is waiting for the g to be defined, and then we like continue the compilation of the body of f. That's how it works. So we can do the same for like the types. If you want to know the type, then you would like be waiting for the type to be resolved. Yeah, I could have that. Eval AST body. Is eval AST just a function? I guess it is, right? Yeah, so we're just having this standard library. I think I just having the standard library, something like eval AST is a function for all t native eval AST, which is type AST into t, right? So we basically we evaluate AST into some type, which it needs to be defined after the AST is defined, I guess. But yeah, something like this. Then it will say native eval AST is not found, so I need to implement this actually in the interpreter. Natives insert function eval AST. So this over here, I'm specifying the type, right? It's a function type where argument is AST, context t, and result is new not inferred type last result. And the definition of the function itself. Just function type. AST value. Let's see. So I want AST is the AST into inferred into AST. We know that it is AST, and then a result type is function type a result. So we just say cast dot eval AST. We do async move to here. We just evaluate the AST with the expected type being some result type, right? Is that it? Function type should be function type. Cast should be straight. Cannot borrow cast as mutable. Let's see if this works. This is all the implementation, right? I just evaluate the AST. This might work. Equal doesn't work for type and type. Yeah. So I need to make sure that we can compare to types, which I don't do right now. Equal. Binary comparison operator. This. I guess like equality is not exactly that. Like I should not be able to compare two types if they're less than the other one, right? So this is where Rust macros, for example, are not exactly this. So like this is a macro which has the operator that I'm defining, but I want, if the operator is specifically the equal operator, then I want to have some more things here, right? Although, I mean, technically, I think my types do implement ORD. Do they? I'm not sure. Where is type? Does this implement? No. Or does it? It doesn't implement partial ORD. Yeah. So I can compare types right now. Actually. So I can just implement this like that. If I have the type and I have another type, then I can just compare them. To do only equality. Like types should only only implement equality, right? Not the ordering, maybe. There you go. I had an int 32. So here you go. Here I can show that this is working with the actual basically inspection and not on the AST level, right? Because if over here I say x, right, and I say that x is equal to int 32, because I can do that, then this also will say that, wait, what? Equal doesn't work for type and type? Hold on. Oh, because this is, yeah, I want this to be like const. Because this is running at compile time, right? Yeah. There you go. Had an int32, right? This is x, not an int32, but it still knows that it's an int32 because it's actually evaluating this. We can also say something like, yeah, I don't know. X.0, where x is the int32 and like string, right? This would also say that I had an int32, but x.1 is basically not an int32, right? So the only thing that is like missing, we could also have this be like you said, we want to have a type of operator to know what's the type of the symbol, right? Which means that I just need to implement the type of. It is also very simple to implement. I can do it right now. I guess. Also, we can do this. Underscore. Underscore means please infer. So what is this going to say? It says type is not inferred, fail to hash, right? So this is it, right? Over here, when I'm evaluating this, I have evaluated this to a not inferred type. This is where we would need to wait for it to be actually inferred, right? So maybe like when I'm like evaluating things, right? You just saw this code that I implemented, right? I just say into inferred in the yeah, over here, right? We say this as inferred, but as inferred and then question mark, which means that basically if it's not inferred right now, I'm going to throw an error. So instead over here, I should say like you know, await inferred, await, something like this, so that this code will only work like this code will only be like evaluated once it actually is inferred, you know? That would be the addition that I would do, right? But if we make sure that it is actually inferred over here, right? Something like let underscore of type x.0 is equal to 123, which is int 32, right? By doing this, we are basically saying that x.0 is equal to int 32, so now it is going to be inferred. And now, no, wait, hold on, no, it's not inferred. Why not? Comp time dbgx. Wait, what? Type is not inferred. Oh, cast key. Wait, what? Hold on, something is not working here. Maybe the .0 is not working actually. Like I can do this without the .0. Oh, maybe I don't know the type here. This should be tuple of types, right? Maybe this will work. Yeah, there you go. It's good for the type of X because this can mean two things. Yeah, so there you go. If I comment this code, then the type of X, then X is not inferred yet. Wait, what? Hold on a second. Comp time dbgx. It says that it's not an int. It's a type not inferred. Not an int. X.0 is a not inferred type. Oh, wait a second. Yeah, I know. Wait, what? It says that it's not an int 32. So I know that this is a type and this is a type. I guess it's because if I try to see if two types are equal and one of them is not inferred, then it's actually saying that they are not equal. It's in the inference. Partial act for this. Yeah, see if they are both inferred, that I see that they are the same. Otherwise, yeah, this is maybe wrong actually. Yeah, I don't have a way to see if the types are inferred fully, maybe. Not sure if I can change it right now. Well, I mean, I guess I can do, if they are both types, then types need to be inferred, I guess. I can do at least that. Left-hand side is left-hand side inferred. Right-hand side is right-hand side inferred. No method is inferred for maybe not inferred type shape. There is a method inferred with a similar name. Inferred. What? Hold on. Let x is a type x dot inferred. Wait, why is there a no as inferred? Is that like a different thing that is, this is only for values? Expect inferred. Make it that they are the same. Yeah, there you go. Variable is not inferred. And so now this is not inferred and this is inferred. There you go. Sure. Let's just do a quick type of, because why not? Type of. We have a macro type of, so I just need to implement it already. Thanks for the sub. Nerdcell.
Sub not inferred.
Let's change this example of the oh shit, what was it called? Type inspect. So let's just say that we don't do this. We just say that x, let's just say that let x be the int 1 to 3. So I just have a macro with x as a thing. So I just evaluate AST once again. What's the type of body, right? That's what I want. So then we will inspect the type of the symbol here, right? And then based on that type, we can generate two different pieces of code. So this is not going to work because the type of is defined in the syntax, but it's not actually implemented. So in compiler, I need to go somewhere here, macro type of. This should be really simple, I think. Let's see, macro type of. So type of is always an expression, right? Okay. So then we have that. STD syntax, type of expression, right? So this into single named expression. This is the expression which I want to get the type of. So we just have the compiled. So the type of is basically the same as having a constant, right? So I'm just going to have a constant expression constant, right? Where the value where the value is what is this? Just a value. So a value is a type, right? Is a type. So what's the type? So type is, I will need to compile a new expression and a new thing, right? So I compile the expression. This needs to be compilable, right? I compile this into an expression, and I return its type, right? So I compile into an expression, and I say data type. That's literally what I do, right? I compile an expression, and I see what's the type of it. I might want to like introduce a scope here in case generate some enter, like, let's just enter a scope here before compiling. I think this should just work. Add an int32. Let's have a REPL. Look at this. So I have a let x be 1, 2, 3, right? What is x? X is a 1, 2, 3 of type int32. What is type of x? It is type int32. There you go, right? What is type of x? It is a type, right? And what's the type of x? It still is a type. That makes sense, right? So I can do basically, what is the type of 2 plus 2, for example? It still is a not inferred thing, right? But if I say that this has type int32, then we know that what the type is. If I do, if I only specify the type of one of these operands, then we still know that, like, since I know one of the types, I know that the type of the sum is the same as the type of one of the arguments. That's how it works right now, at least. So we can do whatever. What's like a good example? What do you use type of for? We can have any expression here, right? And it just works. I can also assign the type of to a variable and then use it for something. What about division? Should be a float to be expected? Not right now, but yeah. I should get rid of the division of integers with the normal division operator. But basically we can say like parse let's see here. We can write code like this, you know, let x be parse 1, 2, 3, and then I say type of x, right? We can do type of this thing. So this is not inferred, right? Which is why we couldn't evaluate this. But if I say that it's parsing int32, then we know that it's going to be an int32. Yeah, I don't know. I don't know what. I mean, this just makes sense to have a type of. Okay. So yeah, by combining macros, evaluating AST, and the type of, we can inspect the types of identifiers when generating code, right? That's the idea here. Right? Okay, let's see. What else is there? Reflection at runtime. At the hot loops, a game can be very static, but its many tentacles games are more often than not very dynamic. I'll be brief and honest. If I cannot put a type in a variable, pass a type to a function, list the fields of a type, and then serialize a reference to a type, I have no business with your language. Simple as that. So you want to be having types as variables, which is literally what cast is doing, right? Everything is first class. Types are values. I cannot like list the fields of a type yet. We can add that later. This is doable. But they say I have no business with your language. What are the languages that can do that? There's not a lot, right? So like in C#, in Java, you have this this is a runtime reflection, basically, right? Well, I guess there is a lot of languages. Those languages that are interpreted can do that, right? Which is basically Java and C#, they are interpreted. Their runtime is interpreting the thing. Help Gorley or reading, yeah. No, we don't only read. I implemented a couple cool things for the language too. Hello Veldak. List the fields of a types, methods, and serialize the reference to the type. Have no business with your language. Simple as that. For performance reasons, the compile time variant of reflection is preferable, yes, but there is beauty in the fact that some languages let me write draw inspector type function that lets me draw the user interface associated to that type, as I would do my day-to-day code, no fuss. Yeah. No, I guess I agree with that. So like this would not like we don't want to generate a separate draw inspector code for every like type. We want this to be done at runtime. I think I agree with that. Like this means less code bloat. It compiles faster if we do the the reflection at runtime, right? But we also want to be able to like maybe, yeah, I don't know. Like it depends. It depends. Sometimes we want the things to be at runtime. Sometimes we want the things to be at compile time. I agree with that, I guess. Hello, everybody. I'm writing that code at this very moment. Wait, what? Which code? This code, draw inspector with a type? Recursively fetching doc comments for any struct and outputting them in default config file. Fetching doc comments for any struct and outputting them in default config file. Later to be generated the GUI from arbitrary types. Yeah, I guess. So I mean, in Rust this is possible, but you like if you want this to be done at runtime, then you need to like derive some trait for your struct, which allows you to inspect the type at runtime. Right? And then this structure, like what is the type, is dependent on the library that implements that runtime reflection. So you have like Beaver reflection and other alternatives already, like Faceit. Yeah. I showed you the Faceit myself, didn't I? You actually use this thing? Or what? So, I mean, I did something similar to that, but like myself. To have reflection on the types. To do code generation, literally. So this is implementable as a library. The runtime reflection, basically. Doing all this at compile time involves a higher mental effort because you need to reason about different compilation stages your code will go through. Compilation stages. Well, I don't know. Like, hold on. Is this true? Doing all of this at compile time involves a higher mental model because you need to reason about different compilation stages your code will go through. So, I mean, why do you... Okay, well, first of all, we don't have compilation stages in cast. The interpretation and, like, the compiling and, like... yeah, I don't think we have the compilation stages at all. I guess there is a stage which is, like, parsing the AST. The only thing is right now separated into a stage. I guess lexing. There's lexing, parsing, and then there's just one stage. Interpreting tokens is easy as fuck. Higher mental effort because you need to reason about different compilation stages. Sometimes you just want to get the job done, and these things don't need to run that fast. Your players will never see them. No compile time system beats the ergonomics of runtime reflection. I don't think that's true. I don't think that's true. The only, like, I don't think runtime reflection is better in terms of ergonomics compared to runtime to compile time reflection, because it's literally the same thing if implemented properly with in a language. I think the only difference would be the compilation times. That's the benefit that I see. So you don't generate like 100 functions like this for every type. You just have one, and it just runs. But then you like trade off performance for compilation time, basically. Yeah, that makes sense. Whatever the Lispers are excited about, I guess. And last but not least, the Lisp style macros. I found this is not something I care about that much, but it feels worth including because I low-key miss it when it's not there. I'm talking about extending the syntax of your language by writing a function that takes the shape of the AST at compile time, reshapes it, and spits it back. So there you go. What we have done, literally, we can extend the syntax of the language by writing a function which takes the AST and then spits the ASTs back. Yes. This is the most overly hyped idea in metaprogramming. You've surely read all about it, so I'll save you the long-winded explanation. And if you need it, just trigger an info dump. But I mean, this is the macro that is used to do basically... That's literally how you just do the code generation, right? And if you need to just trigger an info dump from the nearest Lisper by asking why the parentheses look so ugly. Now, I only want the Lisp style macros if they won't kill my ability to use an LSP. It can be done, just give macro authors the tool they need and they will happily do it for you. If I have to pick between the two, I prefer the good LSP over macros. But if you can pull off both, you have my vote. Yeah, we need to like look at the LSPs too at some point. Wish Facet could be done at compile time too. Isn't Facet done at compile time? They are generating the const functions. Oh wait, I mean, yeah. They are generating the const functions. Wait, no. Facet is implementing the const functions, which means that they can be used at compile time in the const context in Rust. You can just not use the const functions in Rust to generate code. That's the problem. Like, you cannot invoke a const function from inside a macro. That's the problem. But maybe you can just slap const on everything you can, yes. Like, but then the problem with Rust is that not everything can be like a const, right? But they are like expanding the possibilities of the things that you can do in const. But since we are building the language from scratch, we just say that everything can be done at compile time. I will need to restrict it though. Right now we can do literally everything, but we want to like basically use the context system to restrict what can be done at compile time too. Functions in trait impulse cannot be declared as const. This is bullshit. trait function const trust is like it. Where are we with const associated functions and traits? Like it's supposed to work eventually, right? They're just like very slow at making the const works. Revamped const trait impl, aka RFC. Let's see. Impl const trait, where trait impls, all methods are const. Closed. We will process RFC for now. The content is likely still desired, but we want to do more experimentation and will reopen when the designs seem closer to be settled. Maybe there is something in Nightly for it though. Are you using Nightly? I don't know. Experiment with effect-based desugaring for maybe const functionality. Yeah, there is like the maybe const functionality. In 2024, they planned to finish experimenting with this. Const traits. Rust compile time functionalities are greatly limited in terms of expressivity because const functions currently do not have access to generic trait bounds as runtime functions do. It will run a lot of code. It will be run at compile time. There's a link to like an issue here. Track an issue. This. Prepare const trait for stabilization. Like, I mean, what do you mean for stabilization? It means that it's implemented in Nightly, right? If they're preparing for stabilization. What's the feature called? On March 20, they opened the RFC. Make trait methods callable in contexts. Allow marking trait declarations as const implementable. Allow marking trait impls as const. Yeah, something like this. I don't know, like, what's the implementation status? This is the tracking issue. No, that's something else. Last week. Like, there's something happening right now about this, right? Basically. Equal const trait. Const trait. Const always trait. Const true trait. Huh? Const functions don't work in trait implementations. Could we hold my beer? Let's look it up. New way of procrastination unlocked. No, I mean, I like looking at what's the current state in Rust. They're definitely improving things. But I don't think that compile time evaluation in Rust is going to be like as powerful as, like, I don't know, in Zig anytime soon. In the next 10 years, I don't think it's going to be as powerful. I mean, I don't know, maybe 10 years we will get something powerful, but I don't know, not soon. Whatever the Lispers are about. Okay, they have my vote if I can implement both. I just need to look into the LSPs. I'm pretty sure that macros are not really like why are macros bad for the language servers? Why? Well, I mean, just my language server needs to be able to expand the macros, right? Like, and then we will be able to like hover over symbols and everything. I don't see how macros are actually like bad for LSPs. And what do you mean by you just give macro authors the tools they need? Like, what is the tools that the macro authors need? Well, I guess like if I just do it with the expansion of the macros, then I cannot like I want to have like some custom like hover maybe functionality if I use a specific syntax, maybe. Yeah, maybe. Yeah. But like with just the expansion, I would be able to like hover over like a symbol which is being used in like in a macro by expanding the macro and seeing how it's used in the expanded code, so I know the information about the symbol still, right? You don't have to see adaptations of TypeScript type system. You really miss that. Key enum number thingy, like a dictionary object with predefined keys. Plus a corresponding value. Yeah, I guess. Well, I mean, I guess you have the like what's this thing called, like perfect hash map? Rust. Compile time static maps for Rust. You have enum keyword, loop continue break extern. So you want to have no, this is like a little different. You want like a map from this enum into something else. This creates a hash map from strings, right? Only. I mean, I guess it doesn't need to be perfect, right? Just want to be able to construct a map from an enum. No, like I guess like what Devnia means is that like you can have an enum foo, right? A B C. So if in Rust, if you just say map is like, you know, a hash map from foo into like some value, then this does not guarantee that the value exists for every variant of foo, right? When you do this in TypeScript, I'm pretty sure if you say key is enum, then it means that like the number, like the like all of these keys exist basically in this map, right? That's what it means, I'm pretty sure, right? So we don't want just a hash map. We want a hash map which is defined for all of the variants here. So this it is done like on the type level in TypeScript. Yeah, I agree. It's a nice thing to have. Well, I mean, we can just generate this with like I'm just thinking if in cast I have you know, like this so what do you call it, the thingy, right? That's what you called it. So we have for all, like we have an enum, right? This enum needs to be something that's enumeratable, right? I mean, I guess we can just have like yeah, I mean, it can be just an enum, right? So I want to generate a type where so I want to generate a type which is basically like a tuple where every field has like the thing, you know? So I want to be able to generate a new type here. I don't have a syntax for it, but I guess it's, yeah, it's like first of all we need type inspection, right? We need to be able to say like if E is a type, right? It's not just any type, right? It should be like, it should be a type like it should be an enum, like literally, right? Or something. Like I'm not sure how to write this, but we basically need to have like be able to have the variance of E, right? And this is let's say like a list of reflection data, right? So this is a list of variant like metadata basically, right? And then based on this list, I want to construct a new tuple, right? And then I would want to like map this. So in order to construct a new tuple, we need to basically have a way to like convert a list into a tuple or something. I mean, at the same time, I wanted to get rid of lists because lists is just like variadic tuples or something. Yeah, because E variance is not just a list, right? It's basically like it's something like this. A list is basically this, I think, a variadic tuple. So then I would be able to just map this, you know, I map each variant to, like, you know, if this is a variant, then I want to have the variant, I mean, and I don't care about the variant. Just for each variant, I want to introduce like the value, right? The value. So this is a map from E into value, like this. So value is a type, right? So we do this, and this is my resulting tuple, right? I just want to generate a type like this, I think. And that's all, kind of. But then I would need to like have like the index operator too. So right now, I implemented earlier the fact that we can have like a tuple 1, 2, 3. We can do dot 0 to get the first element, right? The element with index 0. But for maps, we need like the index operator. I'm wondering if I actually need the index operator, guys. Like, isn't the index just like dot, and then we can have any expression here, you know? What if I have like this like thingy from like my enum into like an int32, right? Where, you know, like my enum is like, I don't know, A or B or C, something like this. So we have like map of this type, something, and I would just say map dot dot A dot my enum dot A. What if at is indexing? Yeah, we can do at as indexing, right? But then, like, how is indexing different from getting a field? It's not really any different, right? That's how it works in JavaScript. If you're trying to do a dot, it's basically the same as getting the index with this, like dot is the same as indexing in JavaScript, right? Index at array. Yeah, it would make more sense if we say index at array. I mean array at index at array. But in feels better. Yeah, I think we wanted to like field at map. So it's basically like the if we want it to be the other way around. So like a map dot is getting the element like with this key or like with this field name, right? And if we want to just turn them around, because sometimes it's nice to have a syntax which like swaps things over, we'll just say my enum dot a at map, and this is like the same thing as this. I'm just asking, how important is it that the like, because everyone is used to square brackets being used as indexing, right? But is it actually that important to use the square brackets. Right, because right now I'm using square brackets for like generics, right? You can see it over here, right? I'm using like this syntax for instantiating a generic stuff. And I think I like it. I would need to have a different syntax for instantiating generics, or I would need to have a different syntax for like indexing. I just don't have indexing right now at all. When did I add enum type? I mean, I have the sum types always. This is not working. No. Don't worry about this. This is imaginary. I don't have the inspection of the types yet, where I would get all of the variants of the enum. Like when a language keeps the special characters familiar. Well, I mean, at the same time, Python uses the square brackets for both instantiating templates and indexing, right? If you have Python typing, you can do you do basically this. So basically, indexing a generic is instantiating the generic, right? So they use the same syntax for both. Maybe I can do the both then with the square brackets. That's what Python uses, so it's familiar, right? It's just weird to me that the dot syntax is like I'm parsing, I can parse this already. Map dot opening bracket and enum a. This is already parsable, right? Yeah, look at this. I can just do this. A dot B is just a field access of object A with a field B, right? But I can say A dot B plus 2, and this will this is field access from object A into the field which is B plus 2, right? So I can already parse this, but this doesn't mean anything. And I mean, how is that? This is just indexing, right? You're fine with this syntax? Yeah. Like, why do I need to restrict this to only having the identifiers and like numbers? Array pointer index. Yeah. Can do emojis, of course, but I will not. Alright, anyway. Let's not talk about syntax too much. Syntax is important, but we can talk about it all day. Compilers shouldn't be black boxes. The closer a compiler gets to a library, the happier I am. So basically, this is the whole idea of cast, right? This language is going to make this person the happiest thing ever, right? The compiler itself is treated as a value in cast. Like the compiler is nothing. There's nothing like. It's just the compiler is just a thing that you can do anything with, just like with anything else. Cast perfect language confirmed. Yeah. Plus comma with no white space? Huh? Job 0 inner field. Meet me at the top of the ivory tower. If there is one topic that causes more collective thonk cycles, CPU cycles, to be spent in a language design than memory management, that can only be type systems. I'll start the section by misquoting several smart people by saying that a good type system is like dancing with the compiler. No words, only feelings. The compiler's warm embrace, and also the compiler occasionally stepping on your toe and vomiting a 3000 line trait solver error on top of your dress. In general, I like types, and I like typing them out. As often as I often put it, if your compiler cannot even tell its strings from its ints, I have no business with it. I don't care about your, well, it's technically strongly dynamically typed pedantry. What I care about is about the language saving me from my own stupidity. Yes, I agree with that. But at the same time, I acknowledge that can take many shapes behind Haskell's. Because more often than not, it's less about the types and more about the tooling. I can agree with that. Isn't that the reason why I dropped OCaml? Although I was maybe I had a skill issue with the tooling because I was told that Rust tooling sucks compared to OCaml tooling by someone. But the types are the tooling, yes. But I mean, you want like, I mean, yeah, types are the tooling, and then you need to have the tooling that, like, helps you write code, like the language server, needs to be there. The language server, though, needs types to work better, right? OCaml has way too much inference. Well, you can, like, I mean, so in Rust, you are required to type out the function types, right? In OCaml, you don't. But in, like, in Haskell also, you don't need to do that. But it still is a good like habit to type the functions in those languages, so that like there is less inference and some things are explicit. It pains me to say, as much as anyone else, that Microsoft proved that you can take JavaScript and Python and turn them into something I don't mind touching as long as the tooling around them is good. And yes, I hear you. Why cast a shadow on the corporate monster over this fun and so far light-hearted post? Will believe it or not, I'm trying to take a bittersweet point here. Just need a few thousand more words. Hang on. But for now, I'll get back on track by saying that many people don't care about the compiler, they care about the tooling. What? What does it even mean? Now, if you are one of those people who spent way too much time looking at the terminal output of GCC, you may be surprised by this, but most people have the compiler integrated in their editor in a tight feedback loop. Yes, the LSP. Sure. These days we just use this thing called language server. Down. My point is that your type system is important, very much so, but the way you present the type system to your user is even more important. You need good error messages, you need a good and responsive and fast LSP, and sometimes that means making compromises. I don't understand how is this making compromises. Like the type, if you don't have the information in the type system, then how is your language server going to know that information? Like, you cannot show something that doesn't exist. So if you want your tooling, if you want the language server to be better, you need the type system to be better, no? What are they saying here? Let's take a stab at Scala now and hereby declare that no language shall ever vomit the equivalent of "I couldn't solve this restriction system in time, sorry" upon their users. Never. If your type system is so complicated that prevents your tooling from offering a pleasant user experience, your type system is too complicated. Okay, so like, okay, the compromise here is either have the information and show it to the user, or not have the information, not show anything to the user, but then it's faster, right? That's the compromise. If you don't have the, if you like, imagine a language that has no typing, so that you don't, you cannot like hover on a thing and know its type at all. Like that's instant, right? If you don't show anything, then it's instant. Right? Well, I don't mind occasional trip to the Ivory Tower myself. Believe me, I know my way around the type fuckery. As far as game development is concerned, I believe our requirements are actually quite simple. In general, a language for game dev should spend its innovation points elsewhere and leave dependent types for whoever needs them. I don't agree. I'm gonna make a list of things I want or don't want in a type system, but to be honest, I don't feel quantified. After spending years chained up at Rich Hickey's dungeon inside the Ivory Tower, I have learned to embrace whatever is there and try to make it work. But if I were to write such a list, it would most likely involve things like letting me define my own generic types and structures, as long as most accessible users of higher order functions as lambdas. I think it's just like time needs to pass. I think maybe, or maybe like the languages with dependent types, they're like they have very, like, I have not tried myself the language with the dependent types. But I mean, it's just the implementation problem, right? You like the fact that the Rust language server is slow. Like it doesn't mean that a language like Rust can exist where the language server is fast, right? It's a skill issue. I mean, it's a skill issue on the implementers of the compilers, right? I mean, I don't know. I've not implemented something that's a fast language server. Maybe I will have a skill issue myself, but I don't think the problem is like having dependent types or something. Well, I mean, since we have like a language which has which can do anything at compile time, basically, right? Like think about Zig. Is Zig actually fast, the language server there? Because in order for the language server in Zig to work, it literally needs to just run arbitrary code at compile time, right? Because like that's how you know the type, right? You need to run the function to know what it is. If you have a big project in Zig, I only like played with Zig a little bit, right? And on my small tiny project that I was working with, the language server was, I guess, okay. I think I remember it being okay for Zig at least, right? But like if we are getting to, like, I don't know, how do I know the total amount of lines of code in all of my dependencies combined? Is there such a thing in Rust? Get total lines of code in all dependencies. Cargo lock. Nix search, Nix packages, cargo lock. Is this in Nix packages maybe? Nah. Cargo install, cargo lock. Let's see. Like when your project becomes that big, I'm wondering if the Zig compiler is going to be good. What is this system called? I'm not too familiar with OCaml, but type person is name, string, age, int, let, unrelated. The yielding unrelated to be a function of type is too much inference. Yeah. Yeah, I mean, I just don't like how it works in OCaml. So in OCaml, when you have the Camel playground, that's not the playground. Hello. Wait, can I show the type of the thing? Yeah, unrelated is into person, right? So yeah, it knows that this returns a person. Why? Oh wait, they have language server on the playground. Nice. We can hover things, and we can know the type. Look at this. So yeah, basically the way it works in OCaml is just like it's inferring the type of this struct with the name of the arguments. And if there is multiple structs that are corresponding to this, then it's like the last type that has been like defined or something. I just don't like how this works. You can compare this though to the way Zig does it, and I think Zig does it pretty well. So in order for Zig to work, like this is not going to be just inferred in Zig, but it needs to be like this should only be inferred to be a person if a person exists somewhere else in our like inference chain, you know. It's similar to if you also the other thing that is similar to this in OCaml is if you have like the sum type, the algebraic data type, and enum, right? Then how do you do this? Type foo is A or B. Is that how you do it? Right? So let foo let f is A. Right? So this over here is inferred to be of type foo, like, right? In Rust we say foo : A, right? Or option : sum or something. But over here we can just say the name of the constructor and just infers automatically to be of type foo. And if you have multiple types which can have the constructors with the same name, that it will use like the last type, and this is very annoying in my opinion. So I want this to be just done with like this should not be automatically inferred here. This should be inferred only if I use it somewhere where a foo is is needed, basically. Yeah, inferring from usage, not based on just names, is what I want. And I'm pretty sure Zig does this, although Zig, like, their type inference is like not as powerful as like in Rust, right? They cannot infer something that is like they only have like forward inference, right? But yeah, if A is only a constructor and not a type, it should be namespace like in Rust. Well, I mean, so here's how it works in cast, right? I can show you in cast. So I can say debug debug sum123, right? What is this? The literal type could not be inferred. Sure. Let's say let x be sum123 debug x 1 to 3. Let's just say hello, like this, right? Type is not inferred, failed to hash. So like it's not inferring anything. So this will only work if I say that this is an optional string. This will work. Otherwise, it's not inferring automatically that this is an option, because I can have another type which also has the sum constructor, right? So this is based on inference. I know that this is a variant with the which is named sum, but I don't know which type has this variant yet when I just see this in code. Can I do option sum? Yeah, I can do that too. Yeah, I can do option underscore sum, I think. Maybe not. Maybe the syntax is different. Let me check. Maybe I didn't do this yet, but I should be able to do that, yeah. Macro variant. Wait, this is just commented out. Why is this commented out? Let's see. Just REPL. I can just do option underscore sum 1, 2, 3, right? And then it just works. Well, I mean, this also works, right? But this says that this is variant sum 1, 2, 3 of not inferred, right? So you see the difference here? In this case, we know that this is a type option int32. And in this case, we know that it's a variant with the value, like label sum, but we don't know the actual type. That's the difference. Can I do just option sum? I think this should have some auto instantiation though. I can do that. I can make this work too. Macro variant. Let me just fix this right now. Auto instantiate. We just have this on expression. Yeah. So we do expression. We compile it and then we auto instantiate. Is this async? It is. With the result. Yeah. Oh, wait. Like this. So if I just do this, then we can just try and write option, and then it will be inferred on like. This is basically the same as doing this. Sum 1, 2, 3, right? But it is automatically inferring it. No, hold on. Expected type template got type in macro. Oh wait, it's a different one. This is a macro type of macro variant. I should not call these macros. It's like built-in syntax, or I don't know, core syntax. What's type? Eval AST, await. Let self compile expression. Type wait question mark. And then so I want to evaluate not the AST, I want to evaluate this doesn't say that it needs to be a type. Okay, sure. So we just compile an expression, then we auto instantiate. Right, and then I say type dot date type infer as type. Is that what I do? I think. And then after this is inferred, I can evaluate it. think this should work. So say option sum 1 2 3, and there we go. There, yeah. Now it's also instantiating it. This is basically a syntax sugar for that, and underscore means infer this, so I can do that. And if this is this is a float 64, then it's going to be a float 1 2 3. But this is defaulting inside the REPL to an int32. Yeah. So this works nice. Auto instantiate type in variants. I should have like auto instantiation in more places though. It's not the only one. But yeah. Anyway, where were we? Dependent types? Something. Why do you not want dependent types? Everybody wants dependent types. They just don't know about it yet. Right? Well, I mean, technically, like, we use dependent types all the time. In fact, right? So a dependent type, just like everybody wants effects. Exactly, yeah. So like, what is a dependent type? You already, you do generic functions all the time, right? You have like a function that works, so like a function parse, right? I don't specify, yeah, I don't show it here, but a function parse is just like basically a function that takes so a parse is just a function that takes t and then returns the function, which is like string into t, right? Or like we can say that it's not a for all. We can just say that this is a function t because like these templates are just normal functions. So this is just a function that takes t, which is a type, and then returns this function. So this over here, this is a dependent type. This is called a dependent function. They mention generics algebra stuff in the next paragraph. Yeah, so like by having just dependent types like this, like generics, they're nothing special. Generics is just a specific generics is just a special case of the dependent types. It's a dependent function, and that's it. Hello, Betcop. Haven't seen you in a while. When is next Betcop stream? I was looking like at like I was searching for the GDC Betcop. Is the video up yet? You made a talk on the GDC, right? Is Godokon no video yet? Oh, it's Godokon, not GDC. Yeah, that's a different thing. Right. I was just interested to see what you did there. Is there like a time line where the video is going to be available? Alright, anyway, I would also have a neutral list of things like type inference. I enjoy it, but I also don't need that much of it. Really? Wait, what? Hindley Milner is cool, but sometimes things get Scala Y and the user experience suffers. I haven't tried Scala. Is there a different problem in Scala? Sometimes a crappy auto that can get the job done just as well. What do you mean a crappy auto? I feel languages are right in converging towards the idea that function parameters should be typed out, but inference for local variables aside of functions is fine. Yeah. So is it like I mean when you're trying to infer too many things and you are don't writing out the types of the functions, then yes, you get like the like, because you are putting more work on the compiler and your user experience suffers because like because there is too much information, because you as like a programmer did not specify this information, so it gets like spit in your face, right? You didn't like Scala, but I don't think inference was the issue. I think they're just like complaining, like Hindley-Milner is allowing you to do like the full program inference, right? Like in OCaml, like in Haskell, you don't need to specify the functions of the types, but like it is still like it still is a good idea to type out the types of your functions in Haskell, right? Because then like the error messages are going to be better and everything, I think, right? So Rust forces this, but I don't think it's like, I don't know, I don't like forcing it. Like, what is a local anyway, right? What is local? Maybe some function that you have is like a local function to your module, right? It's not being exported. Like, why I want that to be inferred then too. But when you want to like expose a public API, it's good to like enforce the types of your public API for sure. And yeah, and in some other places, like if you cannot figure it out in 1 second in your head, then maybe you should like provide the type annotation. Rust inference is not good enough. It keeps failing inference in my closures. What do you mean? Oh, yeah. I mean, yeah. I think I understand. Is my inference going to be better though? Do we have an example of an inference that's failing? I mean, yeah, we do. Yeah. It's kind of easy actually, right? Play rustlang org. We can have a function foo. So I say f is a closure with a like v, where v dot foo, right? And I call f with I don't know, foo, where we have the struct foo, and we have input foo, function foo self. Is this going to complain? Yes. Like, why is this complaining? This is wrong, right? Yeah. I'm pretty sure this should work for me in cast. We can try, I mean. I don't have methods. The problem is methods. So I cannot do that right now. I mean, we can do the fields. Like if this has the thing, right? Foo i32. Just want this to like return v.0, for example. And this also is not going to work, foo 0, right? This also doesn't compile. This is something that will work for me though. Like I don't even need this to be, yeah, we just make 0, 1, for example. And this also doesn't work. Right? Yeah, this is a much simpler example. Let's go to... Why does Rust not infer this though? This is weird. You can have function f, which is v into v0, right? And then we just call this function with 0 and 1. And number literal could not be... Yeah. Is default where I based on dot. Should I have this default where like wait, function is not compiled yet. Oh wait, it's not compiled yet actually. Hold on. Why is this not compiled? You would make it opt out, so this should be like by default the numbers should be like in Rust. Instead of opt in, it should be opt out. Yeah, maybe, I don't know. Well, right now I have it by default in the REPL, but not in like the code. Does it still fail when you do foo v? We can try. Maybe this. Yeah, no, this works. Yes. Yeah, it's the problem with the methods. Doesn't work for me either. I went. Vector type unit got in 32. Oh, wait. Yeah, okay. That's the problem, because I cannot ignore, right? Is this a good thing, by the way? What do you think about this, guys? So I cannot just ignore the output of the function if it is like for the function output to be ignorable, it needs to return a unit. So we can just say like underscore is this. So yeah, if I have this semicolon here, then this is inferred to return unit. Yeah, there you go. This works, right? I mean, I can just dbg this too, and it will just print 0. And if we do the 1, then it will be a 1. Rusting that take is now iterator take instead of option take. Probably automatic gref happening. Also had similar situations, option take when t is also an iterator. Yeah. Yeah, we don't have like methods, and we don't have the deref rings, the deref yet. The deref definitely like can complicate things. We'll see. Say that again. What does the semicolon imply? Semicolon implies that the expression before the semicolon is always returning unit. So you can like in Rust, you can have like any expression before the semicolon, but then you have like a must use attribute on the things. Yeah, it's like everything is a must use. What does it lack a semicolon? It's just same as in Rust. I don't know. If you don't have a semicolon, this is like the last expression in the scope, and this is just the value of the expression. Leave it as warning at least. Why fail? Well, I mean, having it as a warning by default is good. Yeah, maybe I can. Yeah, I can weaken this for sure. I just think that like I have had this bug a lot of times. Like I always want to use a thing, right? Like, why do you want to call a function that returns something and not use it to result? I don't have warnings yet. Yeah, I don't have warnings yet, but yeah. Yeah, I don't know. Maybe this should be a warning. Yeah. Instead of enforcing it. You like, okay, assign lesbian monad. Hello, hi. We have a monad in chat. Okay, assign is value, and always not allow Clippy unit op. Wait, what are you saying? I like okay, assign is value. What is okay, assign is value? Allow Clippy unit op. Clippy lens unit op. There is no unit op in Clippy. Huh? It wants you to assign its value. Okay. And I don't like that. Oh, I see. I understand. Yeah, because the result of assignment is a unit, and you just say okay, assign value. Weird. Well, I mean, in cast, I think I will prefer not using result types, but instead using the effect system with checked exceptions. So instead of saying okay, do something, you just say do something, and if you have the error, you just throw the error, right, and then handle it somewhere. Don't to be confused with just unchecked exceptions, though, which are bad. And then there would be a big no-nos list of things like the type state pattern. Anything people refer to as encoding invariants into the type system. So this person doesn't like enforcing invariants into the type system. If it encodes invariants, but you are just casual about it, then it's all good. What do you mean casual about it? And especially any linear algebra API that tries to abstract over the storage and number of dimensions. A linear algebra API, okay. Like vectors, matrices, which tries to abstract over the storage and number of dimensions with the usage of the plus generics. I mean, I kind of agree with that. Like nullgebra in Rust is kind of ugly. I can agree with the fact that nullgebra is ugly. A matrix 6 by 6 is a matrix with T, which has the dimension here 6, then this, and this abstracts over the storage, which is being stored inside an array. What's the motivation between calling them contexts? Because we are like evaluating functions inside contexts. So effect handlers are contexts which need to be present in order to for us to call a function that is effectful. But the difference between like normal algebraic effects, yeah, also like algebraic effects is a scary word, right? If you are saying monad, then you're going to scare away a lot of people. We don't want to say algebraic effects. But also the difference is that I'm splitting the algebraic effect system into two separate things. So there is a context system, which basically is implicit arguments. That's all that there is. It's just an implicit argument system, basically. So, but then when you talk about algebraic effects, then it also is about control flow. So control flow and implicit arguments together make the algebraic effects. So context system plus control flow which is like allowing you to capture the continuation or do the unwinding, is how you get the algebraic effects. So unwinding and like calling with continuation is done separately, basically. And then you combine those two features into the algebraic effect system, if that makes sense. So having the algebraic effect as a primitive, in my opinion, is too high level. Could type parameters be encoded in the effect system, or is the time system weaker than F omega? F omega. So hold on, we have a smart person in chat. F omega. System F omega. Hold on a second. Untyped lambda calculus. System F. Hold on. Let me just read a book real quick to understand what you mean. Implicitly typed system F. Why can I not just go to this? You show me that I can go there and I cannot. 64. Stupid books. Cannot even click the links. Wait. It's because this doesn't exist. Why does it start with chapter 6? Where's chapter 1? It just doesn't exist, that's why. F omega, higher kinded and higher order types. Can you add the type system where types can be values? Oh, yeah. No. We can have types as values, yes. But what do you mean? Could type parameters be encoded in the effect system? What does this question mean? Type parameters be encoded in the effect system. So type parameter is just like the argument to a function, basically, right? You said the context system was essentially implicit parameters. Yeah, we have like this. We have function print, for example, in std, right? This is a function that takes a string, returns unit, but it also needs the right context, right? Which is defining which is like the specific implementation of the right. So this is just like an implicit argument. It's like, I guess in general, if you say like function from A into B with C, it is basically the same as saying that a function takes A and C and returns B, basically. It's literally the same, but this is just implicit. Type parameters are usually inferred instead of giving them implicitly. Yeah. We should be able to infer everything. So we should this makes the inference for like the context system a little more complicated because they're implicit, right? Yeah, for sure. And I need to improve my inference system there too. So by the way, since you are here, maybe you are smart enough to understand this. I've been examining how the effect languages do the effects. So there's basically 3 ways that I know right now. There is the subtyping with effects, where like, I guess, so like all of the implicit arguments like when you say because like there's not only a single implicit argument, right? There's a lot of implicit arguments. So basically the all of the implicit arguments is like a tuple right? But how many fields are in that tuple, we don't know. So it's like a row, and then we can do the so we can like we can do the subtypes on the effects, which is like similar to subtyping on like records, or we can do effect systems with row polymorphism, which is the same as like row polymorphism, or there is like this new technique which is done with the model type system. I don't know if you I tried to understand what exactly is the model type system, but I don't know yet. But this like the motivation here is that it allows you to have easier simpler type annotation. Like think about this map function, right? So a map is a function that takes a function and a list and then maps every element of that list using that function, right? So what's the type here? You can see that we have for all A and B. So A is the element type of list A, right? And B is the element type of list B. And then what is this E, right? So the E is the effects. So like whatever effects has this function, the same effects has like the resulting function, kind of. Have I read modality as a monad? Nah, I have not been reading too much about it. Modality as monad. But yeah, basically what I was saying is that we just saw this annotation and we want it to be simpler, right? The function map. So instead of having this for all A and B and E, we just get rid of this E completely in this system, which is like just simplifying the signature. And we like model of types, we do something. You need a paper that like that too, with fancy arrows and letters on top. No effect polymorphism. No, there is an effect polymorphism, but like for a function like map, you don't need to be polymorphic over the effect. Is the idea here, because instead, like basically when you have a function from A to B, it doesn't like when let me see when I was reading this. From function arrow to effect context, with relative modalities. I'm not going to read this right now. But like the idea is that you like if you don't specify the effects here, it doesn't mean that it is a function that is pure. That is a total function. Instead you have like these relative modalities which say like how the like basically in all the functions you have this like for all, right? This over here, which is called like ambient effects or something, right? Like the effects that we don't actually like write out in the implementation of the function, but they are still there, right? So since we're always polymorphic over that, like basically every single function that uses effects has this, right? Like that's what Coca is doing. It automatically rewrites your functions into being polymorphic over the ambient effect. So instead of that, we have ambient effect like in the context, and we have like the relative something. I don't know. That wouldn't be too restrictive. I don't know. Here's the paper. It's supposed to be not restrictive. No. I I don't understand the entirety of it. I'm just like right now. I was just researching. So originally I thought that I would do the effect system for myself with subtyping. Then I read about how Coca language is doing it, and it doing it with the row polymorphism. So I thought that I should implement row polymorphism, and then somebody linked me this thing, the model effect types, which is basically a better version. As far as I know, it's not implemented in any languages right now. Like it's literally one of the newer papers, 2025 March, right? I don't think it's in any programming language yet. And yeah, and I don't know anything about model types. I tried reading about those. I don't understand exactly what it is. Model homotopy type theory. Yeah, of course. I didn't even like get the homotopy, really. I like hot types that go to a photo shoot. Hello, Raymarch, by the way. You demanded to be corrected ASAP. What? What is this negative attitude in the title? Oh, I'm just referring to this. I'm reading this thing slowly. Did you see this post, Raymarch? The language that never was. So somebody is complaining about Rust and ending up in C# land again. I think is what's happening here. So one of the things that they say is that like you don't need a language with a good type system for the game development. That should not be the priority for the language. Instead, like you don't need dependent types. That's where we were, right? You don't need dependent types. Leave them for those who need it. I want to make a game. I don't need dependent types. That's what they're saying. And then I'm saying that dependent types are there already. You're already using it. It's there in the generics. I'll take, obviously. Okay, they also are saying that like they don't want for some reason the type inference to be good. They want the crappy auto from C++. Or something. But speaking about like Hindley-Milner, we don't have Hindley-Milner exactly because we don't have let polymorphism. And like Rust also doesn't have let polymorphism, so Rust is also not having Hindley-Milner. But let polymorphism is not needed. Let polymorphism. Let me see. I understand this because as a user of OCaml, I almost never rely on inference, even though it's very good. So I don't like we were talking a little earlier that I don't like some things about OCaml inference, specifically the fact that it's inferring the type of the sum type based on just the name of the variant of the type constructor, and not based on its usage. This has been very annoying because I was writing the original version of my language in OCaml, and then also inferring similarly the type of a record just from the fields, not from the usage. I think it's wrong. Down. It meant that I needed like because I was using the like I like having same names in different types. Same like I want to have types like struct types which have the same field names, and it just breaks it. What's annoying is module inference. Oh yeah, modules are also really bad. Yeah. I mean, they're not really bad, but I don't know. I didn't do a lot of OCaml, but I mean, I had like the recursive OCaml records being nominal is annoying. Yeah. I mean, they are not as annoying as the Haskell records, though. Haskell records are even worse. But yeah, GitHub castlang cast. Like, because my language is like very like recursive, right? We have compile time evaluation, so the compiler depends on the interpreter, and then interpreter kind of depends on the compiler. I have like these recursive modules, and that is very much pain in OCaml. And so like everything was like a functor, which specifies its dependencies like this, and then I combined all of the yeah, we have like recursive modules, so these are all my modules. Being recursive. Was I using any MLI files? Let me see. I didn't use MLI files, but we do have like these modules.interpreter. Instead of having the interface files, I specify the signatures of my modules in over here, which is kind of similar to the interface files. These are the signatures. So this is the inference module. It needs to have these functions, right? And interpreter needs to have like these things. All right, anyway. Big no-no list for the... Oh, Ray Marsh, are you still here? A type state pattern is a big no-no. Anything people refer to as encoding invariants in the type system is a big no-no. Especially any linear algebra API that tries to abstract over the store. Yeah, that's what we were. Like, yeah. But I acknowledge these are no-nos are more of a cultural issue. I wouldn't disable these options at the language level. The fact that things are possibles indicate a robust and bug-free experience for the normal uses of the type system, so they stay. Instead, I would disable them at the developer level by using the power of the cult of personality invested in me as a language designer, instructing my minions to point and shame those who use them. I have a hard time reading this. What did they say here? You disagree with that paragraph entirely? Yeah, I think so. I just don't know what they said over here. So, like, you should have the ability to have the type state pattern, but you shouldn't use it or something, is that? Back to Lisp for some esoteric reason. One reason Lispers give up all their types when enrolling into the cult is because types hurt the REPL experience. Have you seen my REPL? No, it doesn't hurt the REPL experience. After all, if code is too static, how could we ever look into the production server and fix bugs? It has custom notation, yeah, but I need to improve it. It's not super useful. I mean, it's not like as powerful as I want it to be yet. Maybe it's too easy to make blogs. I mean, I do agree with like a lot of things here. So like they want a language that has reflection at compile time. We want to have custom metadata, which is like having attributes on things. So that when you inspect the things at compile time and generate code, you want to annotate with your own like custom metadata, right? Like in Serde, you have custom attributes to specify how exactly you want to serialize a thing. You want to be able to generate code. You want to have the reflection at runtime too. And whatever Lispers are about, so like the Lisp macro system, like this is something that I agree with for sure. Have you looked at how Agda and Rock do it? No, I didn't look at Agda and Coq, but I did see like Lean 4. Lean 4 custom notation. So I think I will do something similar to that. I would assume it's similar to what they have in Agda and Rock. Where's the example? Index model. Is this like the reference? No, I don't want the reference. Or do I want the reference? Or do I want the introduction? Maybe it's not here. Extensible parser. Where did I see the example though? Macros? Notations. Show me an example. I guess I should not look at, but yeah, basically, like, I guess the difference is that for my syntax I just specify like the associativity and priority for the entire notation, basically, right? But I should instead say that like this over here, the path, should be something with like priority less than like 100. So that I guess it's important for like at least like binary operations, because this right now says that the left hand side basically should have the priority of less than 19 and right hand side should have the priority of less than 19, so less than my current priority, right? But I want this to be more specific, and also I have a hack because of that for the parentheses, where inside the parentheses this thing can be of any node. Like with this resets the priorities, something. I could infer some of it. Yeah, anyway, I don't, yeah, like it can be improved to support some more syntax, but I mean, it's good enough for now. That's not what I should focus on. Compilers should not be black boxes. Wait, I already read this. So hot reloading. I do remember this post by Loglog Games, why Rust is not a good language for game development, which I also, like, I guess maybe in this I was disagreeing a lot more. ECS solves the cron kind of problem. Yeah, I remember that. I don't remember if I agreed with a lot of points there. Having read comments, the main points people took home was that the thing that matters the most for game development is iteration time. And rightfully so, sure, yeah, I agree with that. I wish a message was clear. Iteration speed is the single most important property of a programming language should optimize for. Well, they did a strike through the game development. I mean, in general, programming language should not optimize for the iteration speed. That's not the most important part. No, I don't agree. For just game development, also, I don't think so. It depends. Sometimes you want to have the iteration speed but that's not the most important aspect, I think. But it would be nice to have. Really good. A more performant code shouldn't be the goal of the language. Well, so there is like, so there is multiple goals, right? Which one has more priority? The fact that your code will run fast, or the fact that you can recompile the code fast? I would say that like iteration speed is more important than performance, personally. But I think that it like if you at some point need performance and you are done iterating, then you should be able to switch the priorities without switching the language. Like basically some code, that's why I want to have like an interpreted and compiled language, and I want some code to be interpreted, some code to be compiled at the same time. A modern game dev language should let me tame the complexity of a lot of state. And that's the only way I see new things becoming possible, rather than having a new tool for doing the same thing. I don't want another language that's good for making Minecraft again. It's not about compilation speed, it's about keeping the flow going. Sure, but not all the time. Compile times are important, but more often than not, what we need is something that keeps us in that flow state, able to iterate and get the perfect game feel. Focus on that feature that will make your brain go burr on the happy brain juice. And well, for that you need something that will let us iterate on the code while the code is running. Sure, yes. So I mean, like we have hot reloading of code that is running. I have not thought about hot code reloading like much, but if my language is basically interpretable and compilable, we compile some subset that needs to be working fast and that we are not iterating on, and then we interpret the other part. And since it is like a scripting language, we can just reload it as if it was just an asset and just interpret it again, right? So like then it just works, and I already have hot reloading because of that, if we use it as a scripting language, right? Yeah. If I want to reload the compiled part, and then well, I mean, so since the compiler is supposed to be like a library feature and not a built-in feature, kind of, then that's not even the problem of the language at all, right? It's the problem of like the target, and like with some targets it's just easier. If you target the bytecode of Java or of the .NET, then it's easier. If you do it with native, do you like I know that it's possible to do the hot reloading. Does language like Golang has hot reloading? That's easy. Not having HMR. What is HMR? In low level is really annoying. This is live reload, not hot module reload. Two completely different things. Use air, except it's not hot module reloading. They use air. So air, since this is just live reloading, it means that when your code is recompiling, it just restarts it automatically or something. The entire thing. It's not hot reloading parts, right? Hot module reloading. I don't know, like I used hot reloading in Java, and while it's nice sometimes, it also leads to some like magical bugs. Another thing. You want to try the sub-second? Sub-second. Dioxus sub-second Rust hot patch engine. Is there a like a blog? This is a new thing. They just announced it 2 months ago. That's right. Hot reloaded TUI. We've been working hard in Dioxus to bring add hot patching to Rust. Sub-second makes it easy to add hot patching support with minimal runtime integration. Under the hood, we're leveraging a bunch tricks and new tech. Automatic dynamic linking of Rust code, out of process code modification, object file diffing with minimal loss of app state. Sub-second Rust rebuilds by manually tracking Rust C code gen fingerprints. WASM support. We're hoping to get out beta very soon. Wait, it's not out yet? So yeah, like if you want this to be done in a native language, then you need like a custom solution for it, right? Like if you want to have a hot reloading in C, easy hot reloading for C. What is this color scheme? Hello? Who highlights the code like that? Dark reader on makes it readable. Hot loading. What we want is code hot loading. Basically, in a way, we pause our program, reload the code, and continue running right when we left off with the new code. Dynamic library. The key technology that makes this possible is dynamic libraries. Yes. Yeah. Load the library and look up the module main. Run the module main's code and save the reference to its heap data. So yeah, basically, like it still means that you basically compile a part of your code into like, or I guess so you can just compile the entire thing into a dynamic library and just load it. But reloading is trivial when you treat all states of memory to be valid, interpreting it as a user error if something breaks. It's easy. Homemade hero has the full explanation how to make it. It's not the hot make hero. User error if something breaks. Yeah, I don't know. I haven't thought much about the hot reloading. Do you have hot reloading in like Haskell? Hot reloading Haskell. or in OCaml? What's swapping in OCaml? So this is basically an interpreter, right? That's how you do it. Just have an interpreter. And I guess I guess it's literally the same as in C, right? You have a basically you just don't call it the interpreter, right? But in C you like open the DLL at runtime and interpret that. You just don't call that an interpreter, but it's literally the same, right? Instead of bytecode, you just open the DLL. Language runtime like C or Rust are built on top of a lot of assumptions about memory states or treating all of them as well is gonna break almost all the time. Yeah. Yeah. Okay, so basically we need to have an interpreter, and we have hot reload, I think. And if our interpreter is like fast enough, we're just cheating this stuff, which we should be able to do because we have a lot of type information. The interpreter can be really fast, right? For me, because I have a lot of information, so I can generate code and cheat it, and it should be really fast, right? Can I call it sexy reloading instead? This is what I want. This is what I expect from my ideal game dev language in terms of hot reloading. Changing code affects the runtime state of the game without restarting it. That's it. My point is that hot reloading, not a big feature to pull off where everything goes. When I played with it, the platform side plus DLL was pretty stable. Of course, you change the memory layout, it will break, but that's totally acceptable. Lots of people treat their C code base like that. Yeah. Yeah, I think by just having the interpreter, it just like solves this issue. Most of the interpreted JITed or otherwise runtime powered languages out there have no real trouble with upholding with the reloading requirements above. Yeah. The problem comes when we try to get some notion of low levelness, you know, like value types. I don't see how this is a problem. Like, it's just a lot of the languages that are interpreted, they don't have value types. Or I mean, like when you reload your or is this no, I don't see how is it different. No. Fear not, for in the land of the low-level languages, a younger and soft-skinned 10-year ago version of John Blow, wholesome alter ego, Casey Muratori, proved all of this possible.
A clean record. All right. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch from scratch. No engine, no libraries. What's going on here? All right.
And see?
These guys are no longer internal. And now I look at what the names of these things are. Well,
Sure. Remember coding that along? Nice. As long as you have a dynamic library, a pair of syscalls, and a tiny bit of patience to remarkable. Yeah, I mean, yeah, sure. So problem solved. What's stopping all those C wannabes from doing the same thing? Well, glad you asked, because at the end of the day, your favorite city placement may quack like a C. It may even look a bit like C, but then you blink and you realize you're stuck with the fucking C ABI. And with that, let's smoothly slide into the next section. The interface of the binary application and why I'm forced to care. By this point, you may have realized I've been typing words about lots of things I only have a vague understanding of. Let me tell you, it's mostly the world's fault. Just wanted to make your screen go beep boop in fun little colors. I did not choose the life where I have. Can you like get rid of like this text? It doesn't matter. So it doesn't. So it, like I only read like 1% of this thing. Let's misdefine the ABI as far as a game developer like me is concerned by saying it is how the computer arranges the bits of your things, especially when those things need to be transported around various parts of your code. Like when you pass a parameter to a function, the ABI is a set of rules that tell the compiler how to do that. And it's important to follow the ABI so that the receiving end knows how to unpack and interpret all of these bits you arranged before jumping to the first instruction of another function. That is, if someone didn't manage to overflow your stack, do some nested things, and suddenly you're jumping into the first instruction of fun ransomware adventure. The reality is that we're stuck with the CABI. At the end of the day, while I still have respect for all these attempts to change it, Rust-Lang. What is this? Karabi ABI. Muratori is very skillful, but he's an absolute moron. I don't know. Or watch them. Promising they will change it. What is this? WebAssembly component model. C isn't a language. Let me point out CABI is a bit of a misnomer because there is no just one CABI. There is one for every combination of CPU architecture, operating system, and then some. So why do we care? I could tell you all the benefits of having a good cross-language interop, which I actually care about, but that's not the main reason we're discussing ABIs. After all, we're happy with a single language, as long as that language is good. And for those cases where we need to call out to the outside world, just use the CABI and write some glue code. Who cares, right? Well, this takes back to the fun nostalgic memories of the previous section. It's hot reloading. All this is still about hot reloading, because the problem is that from Casey's DLL trick is that it works for any language, but if your language isn't C, then you are forced to dumb down to C at the point where you are hot reloadable code and not hot non-reloadable code meet the dynamic library barrier. If you didn't watch the 600 episodes of Handmade Hero, let's take a moment to explain what Casey's DLL trick to hot reloading the game is. What you do is you have a main binary holding your engine code and your game code compiled as a dynamic library. The game code calls into the engine, and the engine is watching the source files for the game code. When the game code files are updated, the engine recompiles the dynamic library, unloads the old code, and then loads in the new fresh dynamic library with the new code. The next time it calls into your game code, the new code runs magic. Okay, yeah, sure. For So like, so you don't reload the code. Like once we are in the dynamic library, we don't like reload the library that is running there, right? What about the languages like C# or Java? If you reload a class and then you have a class that is like working in a thread, like you don't stop the thread, right? So you will only start using the new reloaded class when you use that class from outside. If some code is still running using the old class, it will still keep running, right? Game engine calls the game code and provides the memory. When the game code files are updated, the engine recompiles the dynamic library. Yeah. New reload classes only on new instance creation. Yeah, basically. And provides the memory. Game engine calls the game code and provides the memory. Yeah, I mean the state. Yeah. But how does this work in C? If in C you change like the structure, then how do you like how does it work even for C? If you change the layout of a struct, and then you like have it saved in memory, then you call like your dynamic library again with the old memory, having all the wrong layouts. Is it just going to like break? Or like the idea is that you don't change the layouts. There it is. If you change anything layout, it will fail. So like, I mean, it's the same in C. And if it's the same in C, so like you are not allowed to change the layouts. Why is the problem with Rust? Is the problem with Rust because like on a different compilation, it can change the layout because of the wrapper Rust can like potentially reorder the fields and stuff, right? But if you do a wrapper C everywhere, then it should be perfectly hot reloadable, right? And the way it works like in languages like Java is because like if you change the layout, you basically still have like let's say that you inside your memory you have stored like a class A, and now you have changed like the definition of the class A. You will still use the old layout, and like I mean you will still use the old class until you create the new one, right? But then it assumes the JVM, the Java Virtual Machine, will assume that you have the class which is new or something. So like because it basically works with like runtime reflection, right? Whenever you call a method or something, so it can like break because of that or something. Java reifies every bit of data. Does it reify? Or does it just not allow you to call the method? Like, let's say that you introduce a new method on a class. You hot reload. Are you going to be able to use that method? Or maybe you only allowed to use that method if you didn't introduce any new fields? Or something? If you introduce both like a new field and a new method, then you should not be able to call the method on the old class. Like, how do you even reify that? Like, how you inject and like because like there is, I mean you can have some default value for the new field, right? I guess. And then it will just like break at runtime. you will assume, judging by your code, that the value is always going to be initialized because it is being initialized in the constructor, but you hot reload your code and it's now not initialized and you have a null pointer exception, right? Is that how it works? So we are not allowed to change the data. And like even if we in Beam VM, you have callbacks for that. So what is a callback? A callback for what? For initializing the thing, or do you like provide the migrations? Because I could see it being solved, like, so like you change your code and you also provide the migration. If you see in the memory, the code has changed. So now we have like, this is the old version of this like struct, and this is the new version of this struct. Here is the migration function, which creates the new layout given the old layout. But then it means that you need to write that, right? And that's what you do in the Beam VM. Code reload callback. How messy does that get with nested stuff? I don't know. How does it work in Erlang? Higher order functions and hot order loading. Build a hold 30. I mean, 30 is not having versioning. Right? 30. Yeah, 30 does not have versioning. In Elixir, it's called code change. Elixir code change. Where's the documentation for it? A guide to hot reloading in Elixir. OTP. What is this? One-time password? Set of principles to build robust apps. Tracking the uncertainties. There is a bit of uncertainty about this concept. When we speak of code reload and hot code upgrade, we usually mean an ability to change a runtime process behavior without any negative impact on the process. For example, we may change the behavior of a process that holds a CP/CP connection without terminating this connection. Uncertainty comes up with scaling. The question is if we can upgrade a module, a package, a whole running instance. The basics. Should you code purge in Elixir? What happens if we want to upgrade a code 2 or more times? Let's try this small mix project. Mix new code purge. We have a module code purge where p is a function that returns 314, right? So we launch this, and this is returning 314. And we update it like this. We compile it, and then we reload, right? And this. Or is this not reloading, just loading? Sure. But what happens if we try to reload this module more than once without actually changing it? Not purge. What went wrong? Is because Erlang cannot have two versions of old code. Oh. So you have like old code, you have new code. So you can only have you can only load it again once you have migrated all of the old code. Is that it? Or something? This did return the new thing though. This is because Erlang cannot have two versions of the code. A purge evicts the old code. Code purge. We can upgrade the code in the module again under the purge, but why do we need to control that? Why not purge code automatically? There may still be processing running old code, yes, and we should decide what to do with them during the upgrade. This is also why we have two functions, code purge and code soft purge. So this is just killing all the processes running old code, and this fails if there are any processes running old code. Okay, so it knows if there is old code still running. Okay. Sure. In Rust, if I have option foo struct foo x Easter const where everything is _C, then it won't inline the valid bit. Null state. I mean, if you declare your own option, which is basically an enum with _C. If you do an enum with _C, it doesn't even... I don't know. I don't do much _C. Rust enum _C. What exactly does _C mean on enum? Well, but I'm pretty sure it's not like inlining it, yeah. So like you would have two separate things, right? Even the Rust option, but used in a _C context. But you are not supposed to, like, if you do this C API, then you're not supposed to use options there, because that is not guaranteed to have a specific representation, right? How not to do a code upgrade. First add this to your toy project with the following. So code purge pi, we have start link, spawn link, server, receive, get, send, server. So what is this? Is this like an infinite loop? The server is trying to receive something and then it replies. So like it's a ping pong, but it replies with a P and then it like runs itself again, right? That's what's happening here. That's just a loop. And then receive do spawn link server 0 get PID send PID get self receive okay after 1000 error. All right, I don't know enough of Elixir. When we run the shell, we spawn a server by doing start link. So start link is starting the server. Spawn link. What is spawn link? Is that like a built-in thing? Code purge pi get. So get is sending to the PID. Okay. So we start the link. It returns us the process ID. So this starts the process, right? This returning spawn link returns us the process, so, and then we can get from that process the data, right? So this has spawned the server which is replying with 314. Then we send something to the process and we are receiving it. Yeah, that makes sense. That's easy. So we are getting from this process the 314. Now if I reload, I'll reload the module once without actually changes to the code and try to purge it. Yeah, because we cannot purge. Because it was still running the old process, right? As expected, the server just died, and even the external call couldn't save you. The server didn't receive messages, and so didn't transition to the new code after the first upgrade. This isn't robust. One of the obvious reasons for the failure is that we didn't use OTP libraries dedicated to creating this kind of server. Avoid spawn in real-world software development. In many books and articles, we see code examples demonstrate the power of Elixir or lang, tons of process easily spawned using spawn or spawn link. However, in real-world software, we generally would avoid creating home-brewed servers for or other long-running processes. We should use instead OTP libraries. Even for one-off asynchronous tasks, we shouldn't directly use spawn or spawn link. Elixir has a great alternative for spawn, though. The task module. I don't. Okay, I don't get it. But there's basically like a better version of these in OTP libraries or something. How to do a code upgrade using Gen Server. So Gen Server is the thing from the OTP libraries, right? Whatever that is. So instead we do Gen Server start link, which is different. And then module refers to like what? Like the current module. It's like in Python. And now try to upgrade purge. Nothing bad happens. The reason why is easy to understand. Our PID process doesn't spin in this code. It runs a gen server loop, and we don't update the gen server module code at all. Okay. Genpid is a callback module. So it's a callback module. So this is the module. This is how we initialize the module. That's how we handle call. Reply value. And when we do get, we do gen server call PID. Okay, I think I understand. Like, I mean, but we can do the same thing in like in native languages. What's the problem? Like the only difference is that this is implemented. Like you need basically to write code in a specific way to do it even in Erlang to have like proper code reloading. So you need to do it in a specific way in like Rust too. Also, like this is a dynamically typed language, which is like we're not specifying the types here, right? What would be the what would happen if, like, obviously this code I mean this code specifically just replies with the value that was sent to it, right? So it doesn't matter. But there could be some assumption about like the value here, which wouldn't be correct anymore. Okay, our main change is to keep updating the states of gen server process so that any new code can work. For a single gen server, this can be done through the :sys module and code change callback of the gen server. This is covered in depth on the previous mentioned hot reloading article. So here we'll only briefly demonstrate it. Without closing the previous section, let's update this to the following and compile. So now, when we call get, we call the get handle call get. Okay, so like when we are getting the get, previously we were just returning the value directly, but now we are making value is a st. What is this, like a destructuring of a list? So we expect the state to be a list with a single value. So we just unwrap the value. What is this? Reply value st. Why is this three things? And then code change says that if we have old version, we have a value, and now we have a value in a list. So this is literally the migration, right? So when you code when you hot reload the code, you specify, if you had previously just a value, now you want the value to be in a list, right? What is this colon? Reply. Everything works, and the last call to sysget state demonstrate the state of the action. The state has actually changed. Sysget state PID. Yeah, so the state is now the list of 314, not just 314 like we had before. Right? So this is like the state, or I don't know, this is some action. This is like our state. This is our like new state, and this is what we're, so yeah, we are replying with value, and now our internal state of this like actor or whatever they call it is now this, right? Yeah, so previously we were replying with the value, and we also were setting our internal state to be equal to value. I think that's what it means here. But do you want, when you're doing game development, to write, like, you want the code to be hot reloaded? Do you want to provide the migration functions to migrate the old state into the new state? Also, this works here because value, like, this is a dynamically typed language, right? If you wanted to have a migration like this, so you want to migrate from old state to the new state, which means that inside the code, you should still have the definition of the old state, right? And the new state. And also the old state depends on the version. Over here we have the version as an argument, right? But the type of this actually depends on the version. So if we want to have this in a typed language, these arguments is this is a dependent type basically. So we need to have a dependent type, basically, version, and the type that depends on the version. Right? So we want to have something like this. So we have like versioned. D is basically like a tuple of a version, right? Let's say that version is just an integer, for example, right? So this is version plus the like, you know, T of this version specifically. This cannot be done in Rust, but yeah, since the type here depends on the value of this, yeah, this is V of type version, and this is TV, like this thing, right? Is what we want. A dependent pair. Where type T is basically like for all, is basically a function from the version. I'm writing cast here, right? So we just say like that if version is equal to like 0, then we return like T1. Other, like, right, if version is 1, then we return T2. We want something like this, and then like our actual migration would be basically basically like a versioned T into like the last version, right? So like the actual T that we are using in code to write stuff is like T with the last version, right? Whatever the last version is. So this is our migration, so that we can migrate from any previous version to the last version. Right? I don't know. Is there anything similar to this, but in a typed language? Elixir with types. Type specs. Wait, Elixir comes with an annotation for declaring types and specifications. Elixir is an dynamically typed language, such as the type specifications are never used by the compiler to optimize or modify code. Still, they are useful because they provide documentation, and they're used by tools. So they are actually not going to check. Like, there is no way to like even annotate this function for hot reloading, right? After the code change. Anyway. Elixir, but with static types. Or like in general, is there like any statically typed language with hot reloading? I would assume that the like in C# it runs hot reloading and static types. That's in the Elixir forum. Black boxing fix or hot reloading with static types. How feasible is it? Statically typed version of Erlang was abandoned years ago due to speed and complexity concerns. Oh, what about Gleam? Gleam is a typed language, right? Hold on, Gleam. Gleam is a typed language, right? But it also is working on top of the Erlang VM. What about hot reloading? Gleam dev streams too? Yeah, I know. Gleam. I think they rated me once. And then I said that something. Oh, I think I looked at Gleam and I was like, okay, you don't have traits. I don't want this. They have the system which is similar to OCaml modules instead. Gleam Radiate. Gleam the modern Rust. I don't think Gleam is modern Rust. Gleam is not the modern Rust at all. Hot reloading while in development for Gleam. Radiate will watch any directory you specify for changes. When file is changed in that directory, it will change for a Gleam file, and if it is, the project will be recompiled and all modified modules will be reloaded without having to restart the Beam VM. So why do you need a thing like that? So it's not in the language or something. You cannot just reload it with like the power of the beam. You need some like glue code, right? Change get message to return a hello world and save the file. Radiate news start. I'm just saying what is my source code that needs to be watched. Print every second. Timer subject. Where is there documentation? Right here. I'm wondering specifically about the migrations here and if they do that, like the code change. There is no results found for that. You did not read my message properly. Typical. Isn't Glib so close source? Yeah, I think you're thinking of Mojo. Gleam, I'm pretty sure is open source. Might be wrong. Code on the GitHub over here. We have Gleam. It's written in Rust, actually. Are they not writing the language in itself? That's not the goal. Mojo is the new Rust. Supposed to be, right? Mojo Lang. I thought, are they closed source? Right, CPU, GPU. There is a link to the GitHub. Oh, this is just a modular ink. Mojo GPU puzzles. Learn GPU programming in Mojo by solving puzzles. 9 hours ago. Hold on. There's something happening in the Mojo repository right now. Book. The GPU. This should be interesting to you, Raymarch, right? Let's see something. Device context, create buffers. Is that exactly the thing that you are working with? Synchronize the context? I thought, like, last time I looked at Mojo, it was completely vaporware, I think, where nothing, like, was, like, you couldn't try anything, I think. Is Mojo actually, like, closed source? It's not fully open source at this time. It's not yet fully open source. I want to progressively open more components in the future. Is it Mojo the MLIR language? I don't know. Mojo MLIR. Also Mojo Max Miller. The Mojo is the first major language designed expressly for MLIR. On the MyMojo. The language for next generation compiler technology, of course. A member of the Python family. Oof. Why we chose Python? Because it's dominant. Of course. Python's problems. The two worlds problem. Selling point was that all of the LVM languages are living in the past. Modern computers are different, need new intermediate representation, which is MLIR, etc., etc. Okay. I mean, can you try the Mojo language actually? Get started now. I don't want to see the code. How do I run it? How do I download? Nightly. Stable release. There are stable releases. Wait, there is a stable version. Is already in version 25. They are like further. Like Rust is still on version 1. Mojo CLI. The Mojo command line interface. Mojo. Hold on. If it's already there, I should be able to just get it, right? Nix search Mojo. Mojalicious plugging mail. Mojo is too fast. Am I using NixOS? Yeah, I am. So they have documentation for it and you cannot use it? Create, import. Where to download Mojo? Play. It's free. releases. Mojo and Max. So it's modular. I should look for modular, right? It's not modular. Modular compiler frontend for the Rust language. Rust analyzer is modular compiler frontend. Wait, what? No, it was just evaluating something. Alright, never mind. I don't think it's there. If you have an issue installing browsers, every browser I install is not on the last version. So there are some functionalities like all login to Twitch that do not work. Just wondering if you have the same issue. No, I can log into Twitch for sure. What do you mean? I mean, but I'm using the unstable. What is the, like, I'm using Flakes first of all. And then hold on, look at this. We have NeoVim inside NeoVim. We have I'm using NixOS unstable over here. If you have an old version, maybe you're using in the old branch. Maybe you are still like on like some old NixOS, and maybe they don't update it with the new like browsers for some reason. I don't know. What's my version anyway? I'm using 136.02 Firefox version. Well, the latest one is 138, right? Yeah. Well, I mean, I haven't updated my system, but that's like good enough. Not the unstable. I don't know. I would assume though that like the version. Let's see over here. If you like, you use either unstable or the latest stable one, which is 24.11, right? If you use 23 or like the older one, that you probably need to upgrade, I guess. If you look for Firefox here, the version is also actually 138. So like if you use this version of NixOS, you should be able to have 138, which is the latest stable. Are you sure that your Firefox is not the latest one? Yeah, they have the same versions in the unstable and in stable. All right, anyway, so we have hotcode reloading. The Erlang, I guess, is the okay, is Erlang the best language with like the best support for hot reloading? What programming language has best hot reloading? JavaScript, TypeScript. What about TypeScript? Wait, hold on. So TypeScript is typed. If you hot reload TypeScript I would assume it works the same as hot reloading with JavaScript. Does mean that when you do this, your types just no longer represent the actual like state. What about Dart? Flutter's hot reload is legendary. So I guess maybe like Dart. Is Dart dynamically typed? Dart. Portable, productive language. The Dart language is type safe. It's to use static type shaping. Okay. Search hot reload. TypeScript is fictional though. Yeah. Like, but what about Dart? Or is Dart like compiling to JavaScript? The Dart VM offers a just-in-time. Yeah, they have like the virtual machine. Flutter hot reload. Flutter's hot reload feature helps you quickly and easily experiment. Modify one of the Dart files. What's the difference between hot reload, hot restart, and full restart? Hot reload reloads code changes into the VM and rebuilds the widget tree, preserving the app state. It doesn't rerun main or init state. Hot restarts loads code changes in the VM and restarts the Flutter app, losing the app state. Full restart the iOS, Android, or web app. It takes longer because it also recompiles Java Kotlin. So when you say preserve the state, you have changed some types in your code. How does that work? Already, like if you still have the process running with the old code, right? And like it just works. Don't worry about. So like there are two issues, right? First, it's the there is still a process running with the old code. So Erlang says that we can kill the old code, right? But then there is still the data. So in Erlang, they don't talk about the data because it's a dynamically typed language, I guess. But if in a typed language, you need to... But they still do like the data migration, right? When you do hot reloading in Elixir, you can provide the function that converts the data from the old version to the new version, right? So how do we do this here? The real MVP for sort of loading and are old image-based languages, like Common Lisp or Smalltalks. Image-based languages. Well, Common Lisp is like Common Lisp is also not typed, right? I mean, yeah, most of the Lisps are just dynamically typed languages. So like if it's dynamically typed, it's not a problem, right? You're just going to like have an error at runtime because the type is not correct, right? Like it's not a problem for dynamically typed languages, I think. You just panic if something is not what you expect it to be. If you've changed native code, you must perform a full restart to see the changes take the effect. Previous state is combined with the new code. Okay, Flutter's stateful hot reload preserves the state of the app. This approach now allows you to view the effect of the most recent change only without throwing away the current state. For example, if your app requires a user to log in, you can modify and hot reload a page several levels down in the navigation hierarchy without re-entering your login credentials. State is kept, which is usually the design behavior. If code changes affect the state of your app, the data your app has to work with might not be fully consistent with the data it would have if executed from scratch. The result might be different behavior after hot reload versus a hot restart. But it's like if it's like, so they don't talk about like it's just not consistent, but it's literally a different type, no? Or like for the Dart virtual machine, so the Dart virtual machine is a dynamically typed thing, right? The types, they similarly exist only when we are compiling to the bytecode, and then they're gone, right? So the types that I see in my code no longer represent the state as soon as I hot reload, right? When hot reload is invoked, the host machine looks at the edited code since the last compilation. The following libraries are recompiled. In the library, and the main library, the source code from those libraries can be compiled to the kernel files. The Dart VM reloads all libraries from the new kernel files. So far, no code is re-executed. Because the Flutter framework to trigger, rebuild, relayout, repaint of all existing widgets, and render stuff. Dart kernel is a small high-level language derived from Dart. It is designed to use as an intermediate format for the whole program's analysis and transformations. Is this typed? The kernel language has an in-memory representation in Dart and can be serialized as a binary or text. In-memory intermediate representation. Source AST functions. Wait, they have types in the AST here of this kernel language. You think that there is no solution? Change the types, it will crash. That's acceptable. That's not why you want hot reloading anyways. Yeah, I guess. So like, yeah, like it is relatively, I guess it would be relatively easy to have hot reloading that just replaces existing functions, bodies with new bodies, right? Potentially introducing new functions. If we don't change the layouts and the types, we can have some new types though. Or do you say that like the solution would be basically if I try to run new code with the old data, then it crashes, right? But only like once it actually happens. There are difficulties with long-running functions. So we don't, I mean, if a function is long-running, you hot reload it. So maybe so that's why the Erlang VM is providing you with a way to kill the long-running function that is running old code, right? But then you need to restart it too. let's say that I have a function. Sorry, light mode. If I have a function, let's go to Rust. If I have a function and it does something in a loop, Damn. Easy for them, they have this whole philosophical crash early, crash often. They like crashing. Huh? Okay. But what if, like, imagine if there was a language support which would say like on reload do something. This function is running, and then at some point we recompile this so that this code gets executed. Right? But then the reloading can happen like anywhere inside. Anything that happens inside is being reloaded. But wait, hold on. Can we make this work through like the context effect system? You know, like we have a function foo, which is like, you know, we annotate this like, you know, reloadable. So this thing means that this function is going to be potentially reloaded, right? So this function can only be called from a context that knows how to reload stuff, right? And this is a handler for the reloading, right? So if I call this in in function f, and then inside this function, like we reload the thing, right? So this function has been recompiled. So we trigger this effect. We go to the closest handler of this effect, which is over here, and we just execute this code. Right? And we, like, since this is like an effect, we would get the continuation, right? So this would have the like continuation as an argument. So we like we can drop it, or we can continue running the old code, I guess, or I don't know. Like this basically represents the old code, or maybe we don't have the old code at all, right? Maybe like if we do the reloading, maybe we just don't have like we shouldn't want to run the old code anymore at all, right? But there's potentially the continuation where we left off something. Then before I wrap my whole game in reloadable. Yeah, so like here's the thing, right? You can wrap the whole game in reloadable, so when you reload the game starts from scratch, right? But you can also write the reloading handlers for some like for like some certain scenarios, right? Because when the function is reloading, we are basically running the code in the closest reload handler, right? So if you want not the whole game to be restarted, but only like something, then you just have the reloading handler like in some certain place, right? Not outside of the entire game, but you can have like multiple reload handlers, right? Outside the entire game, or like I guess like on every frame. I don't know. I mean you probably don't want, I don't know, something. Like a proof of concept example of this. Yeah, I guess we yeah, I mean this can work in the interpreter too, right? Like if I want something to be reloadable, then I need to specify what happens when we reload. I think that's totally fine, and I can do this in the interpreter too. I just need to think about it a little more though. I think we I think this is something, but just let me think. Hold on. Like there is some state. There's state, right? We have a mutable state of type state. And when I'm reloading, I want to save the state, right? And continue with that state. But now it was the old version, and now it's the new version. This is, over here, we have a problem. Like the on reload inside the loop means you can reuse the state maintained by the loop. But it means that the state cannot change its layout, right? I mean, if we do this, if we do that, it doesn't matter, right? If the state, so like everything like after we introduce the reload handler can be like dropped, right? But all the variables that are before this is the state that I want to preserve, right? But that means that this cannot be changed though, right? This means that this cannot be changed. But I want it to be changed. The state of the game. Which means that I would need to provide the migrations, I think. So let's say, so like over here we have the continuation. Or maybe we don't want the continuation, we just like stop. Or like, what actually happens? Hold on. So I reload, and then this code just runs. But this code stops. But I want to like capture the state when going like back, right? So I want to have like some state here that needs to be saved. Can I have like the entire state in a single variable? Maybe we just have like reloadable block. You know, we just have a reloadable block which has a state, right? Which has state. Writing migrations would be useful for a game that runs 24/7, but for a game nobody has time for that. Well, I mean, then your migration just has the panic inside. If you don't migrate, then like your code is just not going to work, right? So like you can just capture no state basically, and then you reinitialize the state. Like static capture requirement. I don't think it needs to be static, but this needs to be like versioned or something. Like if we want to change our data, then we need the migration. For a game, nobody has time for that. But like, so then you will need to restart the whole thing, right? So I guess we can have like the simple thing just that just reloads the code, without changing the state. So then we just have this, right? We annotate functions with reloadable, so this can be reloaded. So when we reload, this code just stops. Shouldn't I check then at some points that like this needs to stop and we need to reload it, right? Because I don't like I want to have it inside this loop, you know, like check if needs to be reloaded. Right? And there'll be a derive migrate panic that panics if the struct has changed, and no ops if it didn't. Yeah, I guess maybe I don't know. But if this, then we just say that if checks needs to be reloaded, then we just break the loop and then we restart it. But that's like a different code now is the difference, right? So just writing it normally is different. So like this needs to be like a language support for that, maybe, because of that. Because this actually loads this code. So like this is the code that I want to hot reload, right? So we hot reload this entire expression, basically. And an expression is basically just a like we can just say that this is a function, reloadable main loop. So it's basically like a function main loop. I just don't like expressions and functions, they're not that much different, right? So just say that this is reloadable. And because we have specified this, we check sometimes if it needs to be reloaded. And if it needs, then it just restarts this whole thing. So this doesn't preserve the state is the only problem. But we do... I mean, yeah, like we have the state outside. We cannot change the state. If your memory is in the context state, would it be preserved? Loadable main loop state, something like this, right? We main loop and we mutate the state. Since this is reloadable, this is just going to like stop this and like restart it or something. Maybe we can have like separate blocks, right? Start and like on restart, what do we do? So this would be a function that takes a state. If I try to recompile this, we can check. So like, okay, this over here, it's just an expression, I think, because this is already like calling a function. So this is an expression, and for this expression, I know what it uses, right? And what are the types that we expect. So here's what we can have from the compiler. When we reload this, all of the captured variables need to have the same type. So the type should not change, right? So the interpreter, when entering a reloadable block, should basically record, like serialize the current like information about this expression, which is all the captured variables and their types. And it will just fail to reload if you change this to a different type, right? Or if it is the same type but the type has changed. I don't know. Might need to think more about this, but maybe we can come up with something. And then like my migrations are still maybe a good feature, right? Maybe not for game development, though. Indeed. Like when you are having a game, you can like finish the current. Yeah, like yeah, just the long running processes. Yeah. No. Okay. Maybe sometimes like the migration is super simple and you can just write it. Anyway. Rust, ha 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 ha, no. Alright, so what is this? The ABI. And the ABI matters because of the hot reloading. We're stuck with the C ABI, but I don't think we're actually stuck with C ABI if we work within the same language, right? Swift. Swift has a stable ABI. Apparently. If we lower our expectations from two independently combined binaries created by two separate versions of the compiler running the different machines at different points in time talk to each other, to the much softer requirement that two binaries compiled by the same compiler on the same machine on the same day, without rebooting the computer in between, must talk to each other, then some of the languages on that list above can somewhat hold their ground, but the issue is that there are no guarantees. The main issue is without explicit support for and blessing from the compiler developers, any trick that relies on reloading dynamic libraries doesn't offer a stable ABI, would break at any point. My experience, compiler developers tend to get mad when you remind them their ABI is not stable. It's like my mind, it's unstable for a reason, you know? The language can keep evolving without being restrained by past choices. We're only 20% through. Yeah, I think like some of this is not about like language or something, I'm not sure. There's plenty of things in programming language, so here's a list of more things I would like to appreciate in all my years of computer touching and I value in the context of video game programming. Compilation speed, yes. Debug build performance, yes. Exhaustivity checks, discriminated unions, sure. Everything is an expression, yes. We have that. Operator overloading, yes. Good SIMD support. I don't do SIMD myself. Does that need to be on the language level? Platform support. The assembly of the web. The web assembly. That's the first chapter. Yeah. That's basically it. Is there, how many chapters are there? Is there like the content? Time I set out to make a programming language. Oh yeah, so basically they made their own programming language. There was the Jai talk. Jai is still not released. Now the crab bites the rust. The game development community in Rust has been described by some with SEO juice-fueled newspeak approved words like vibrant and thriving. Sometimes when people are pointing out undeniable flaws, the words adapt and morph into others like incipient or still in its infancy. The success of Rust is a success in storytelling first, language design second. We are the diverse, the robust, the strong. We are responsible. What? Our fight is against them, the others. And to some extent, I actually buy all the rhetorics here. Look, if you cannot write 3 lines of code without invoking undefined behavior, there is something seriously wrong and most likely unfixable with your language. No amount of public whining is going to change that, and no amount of hand waving while screaming safety profiles can get you out of the mess. The good work is appreciated, and it was a necessity. It's also hard to feel more welcome and included when you approach their community as enthusiastic and open-minded newbie. Just don't fly too close to the leadership and your wings won't burn. You will be happy. There is plenty written on the topic already. Once again, about the log games, sure. After spending almost 5 years trying to make a game development in Rust work for me, I feel qualified to at least elaborate on the issues that ultimately brought me to parting ways with it. Even when just having mentioned that, I feel the need to reiterate that my points are about game development. I try to only talk about the things I'm qualified to talk about. A staggering lack of metaprogramming. People praise the Rust macros. Half of the user base comes from C++. Is that true? That half of the Rust user base comes from C++? The other half is from JavaScript. They just haven't seen better. Rust macros are barely... well, I mean, as far as I remember, this article ends up saying that C# is the thing that they end up using. I migrated to Rust from C#. Not the other way around. Oh no, I scrolled. You also came from C#, Nerdsel? I'll put it lightly and say Rust macros are barely adequate to use, a nightmare to author, and ultimately none of my issues I have as a game developer were, while disproportionately blown out of scope and compile time at the same time. Just go back and read that section of metaprogramming. Yeah, sure. All the work already done by the compiler is hidden away from you. No access to AST, no symbol table, no anything that resembles type information. Sure, yeah, I agree with that. Came from Dlang and Python, Ask V. Yeah, I was looking for a language. I was using D language for a little bit, but then I went back to C#. I like D language, but I just kept getting undefined behavior in the seg faults in debug builds. So I went back to C#. Even though I like D language more as a language, it was just annoying. But maybe it was a skill issue, I don't know. Like, I just don't have the... I just didn't have the stack trace to even know what's wrong. In C#, I had the null pointer exception, but it shows me the line of code when something goes wrong. And D language then didn't do that. I don't know better. A language to keep you and your teammates in check. You don't know better? Let Crab take care of it for you. I'm talking about things like the dreaded orphan rule and its glaring lack of escape hatches. Alright, let's talk about orphan rules a little bit, maybe. Orphan rules. What third-party libraries are they talking about? Wait, where? Over here, they also have this sad situation going on with most of the ecosystem depending on a holy trinity of third-party libraries filled with questionable design choices and nobody being up to the task to improve the situation. They're talking about the trinity of the third-party libraries. They are talking about the metaprogramming here. So it's the sin, the quote, and the proc macro too, I think, right? So, and then they say that this person, they like free of sin. So you have like a, like instead of sin, you have this other crate which helps with compile times, I guess, or something. Not sure about questionable choices. What is questionable in those libraries? Maybe there is. I cannot come up with some questionable choice. He really likes sin. Yeah, I don't know. So yeah, there's the orphan rule, and orphan rule, a lot of people are complaining about that, for sure. Orphan rules are a problem, right? Why is orphan rule a problem? Because orphan rules is about the traits and the trait implementations. So I think the actual problem is that implementing a trait is basically modifying global state. So the problem is global state, in my opinion. The global state of the compiler, of course. So when you implement trait for type, you're basically saying some like global compiler state implement trait for type, right? So you do something like this. So I think I want, and this is how it's done like in Cast 2 right now, but I think we need to change this from being global to being local. Whatever that means. So once again, I think this is also doable with like the context system. So when you say implement trait for type, instead of having the global, you say like something like current trait, like trait like map or something, and then you do this inside the current trait map. And if you want to have like some local implementations, you can construct a new map. Orphan rules are to prevent library updates clashing. Yeah. So I think in order for this to work properly though, because obviously we want to import multiple libraries, that basically when you import a library, you also import the implementation of the traits, right? So when you say import library, right now what this does in cast, this imports this as an expression, right? Which is importing the value of of the library, basically, right? So if in library in code I just have the single like character 0, then the value of this is just the value of 0, right? But when I'm importing things, I also want to potentially import the trait implementations, right? So basically when we have an expression, right? We like do something and we return 0, right? All I do right now for this, I infer like the type of the expression, right? That's actually not all we're doing. We're also already inferring for every expression the context that it needs, right? So similar to functions, right? Well, if I have a function foo, which is calling into print, because print requires access to the output, it means that foo also needs access to the output. So if I have not a function but just an expression which has print statement inside, this means that this expression also needs access to the output, right? So when I have an expression that inside contains implementations of traits, we know that this needs access to the trait map or something to mutate it, right? But the problem is then, if I import two libraries and they both like modify the same way, right? We still like can have collisions. That's what the orphan rules are about, right? So how do I do this? So like we can, like we don't want, if I add another library import, the code to break on accident, right? That's what we don't want. Like we can have, like, since this is just like a scripting language, we can say that I import library 1 and then I import library 2, and then this can potentially can fail if we have conflicting trait implementations. But this is bad, right? We don't want this to fail. Or is this okay? If the Rust did not have orphan rules, so I mean, in Rust there are two things, right? There's orphan rules and then there's also conflicting implementations. Those are different things. This can fail in case we have conflicting implementations, right? We don't want to disable that. We only want to disable the orphan rules. What is the orphan rule even here? I mean, I do have the notion of like the current crate, I guess, too. So I could have orphan rule as is. Orphan rule. Like I can like what do we want actually? The current trait map, this is the solution to a different problem. This is the solution to conflicting implementation. Like if I want to have a like scoped implementation of a trait, basically, that's a different thing. That's not the orphan rule. solution. Implement trait for generic unbounded by local definition. Yeah. I'm just like, what do we want to do about that? Like, I'm pretty sure orphan rules are... Isn't it scoped implementation of trait code? Well, I mean, for me, in my language, we just say, like, with some scoped stuff, and this this is there until the end of the scope, kind of. You could instead say with scoped stuff and then like indent this. I mean in Rust you cannot do the scoped implementation of trait anyway. What does this mean? Trait A, implement TA, iterator for T. This means that type T is this over here, this syntax. This means where TA. Oh, build. Type T must be used by the type parameter for some local type. Yeah, this is the orphan rule. Because this trait is not from this crate. If you have your own trait iterator, then you would be able to do that. So either the trait or the type needs to live in this crate. How many orphans created? It has to have a rule in compiler to prevent orphan overflow. Impl default and impl locally. Oh, yeah. So, yeah. So basically, if you're writing a library, then we do want to have the orphan rule, right? But sometimes we want to not have the orphan rule, but it means just that we have the scoped implementation of a trait, right? There's also sometimes a thing with a generic impulse where I cannot do it because they end up intersecting with edge cases. So the intersections, they are solved with a specialization though. I don't think we want to allow intersecting implementations at all. I don't know. Maybe? Do you want to have implement trait or type something? Or then do you want to have implement like local implement trait for type? This thing would have the orphan rule. This one would have no orphan rule, but uses the scoped implementation block. So this is, yeah, I think this is the way, right? So this orphan rule, this uses global implementations map, and this uses the scoped implementations map, right? Impl default might be a bit odd. Yeah, that's why I didn't write impl default. I just say impl. Hello, ghost up potential. Yeah, so this does not use the scoped one, this actually uses the global one. All right. I think that could make sense. So for this to work, we need to dependency order matters. Might be just as odd. No, dependency order should not matter. But like, yeah, like, why? No, it doesn't matter. But it means that you can have, like, if you have local implementations and you are importing like, you know, I want to have like a file which, like, it's not local. Maybe I should not call it local. Like, in terms of Rust, it's not local to a current crate. I want basically the crate to export two sets of trait implementations, right? The crate needs to open to export the trait implementations that have orphan rules and the trait implementations that don't have orphan rules. You know? But then it means that if I import a crate which has the no orphan implementations, then I need to provide the map for it, right? Or if I want this trait implementation to be local to a crate, then I just have like this local implementations map inside, something like this, you know, so that this doesn't actually get exported, which means that I don't think it should be local. Maybe there should be some other like name here. You know what I mean? Because limiting this just to a crate is not good, because sometimes, like, my crate, I want to limit it to my workspace basically, you know, because like my game or something, it consists of multiple crates, and I want to have the trait implementations that are local to my workspace, not local to a single crate. That's too limiting, I think. But limited to a set of crates basically. It doesn't solve the entire problem, as Nerdsel said, as edge cases. Nerdsel has the different problem. It's not about the orphan rules. It's about the it's about the conflicting implementations, which is different. So if you have an implementation, let's say this. We have trait. Trait find int, where we say find int self needs to return i32, right? So let's do something like this. And then I want to have implementation. I want to have implementation find int for i32, find int self i32 is just self. And then we say implement find int for a and b, where b is find int. So if I can find an int in the b, then we can find it in a tuple. I just say self1 find int here, and then we also want to have impl b find int for like i32 and b, find int. This will say conflicting implementations found, because this implementation and this implementation, they are conflicting, right? But I want to find basically, so if I have a tuple and like potentially some nested tuples, I want to find the first integer in this like struct, in this structure. Right? So for this, this is basically a more special case of this. So we can still say that B is find. I mean, B does not need to be find in here, right? But like we want to basically prefer this implementation to this implementation or something. We need to somehow solve the conflict. So far as I know, in Rust, the specialization, they need to be like strictly nested. So since this is over here more specific only if I have this weight bound, then that would work. But then it doesn't work if B is not implementing the find int. And then we would be able, like if we could write the not find int like this, which we cannot do in Rust, then these two are completely not intersecting, right? I mean, this one and this one are completely not intersecting. And then this implementation is nested in this implementation. So since they are just nested, you can make it work. If you have like the intersections without nesting, I think it makes the inference a little more difficult. And yeah, I think it makes sense, kind of. Anyway, that's like a different problem. But yeah, orphan rules, I think there can be some solution for that. Iteration times are bad and the community is hostile towards improvements. Is it? The average Rustacean is very excited about WebAssembly without the web, and its vaporware component model is often brought up as a tool to improve iteration speed for games. Rust makes people focus on the wrong things. Focusing its whole existence on the concept of the lifetimes of variables and their owner would feel a bit misguided, in my opinion. I don't know about that one. There's tendency in the community to be overly hyped by new developments that raise the bar in the amount of shit you can do with types. Return position infiltrate in trade. What is AFIT? Async keeps steering the language in the wrong direction. Hey ChatGPT, write an unhinged blog post to trigger Rust devs joy. So I think like in Rust you have a lot of these features like this. Return position infiltrate in trade. Like, why is it even a feature? I agree with that. It should not be even a feature. It should just be the implication of the like why is it so special cased? I don't like this being special cased at all. It should just work. This kind of random blog posts remind me of people also complaining about Rust async await. Yeah, look at this over here. Async keeps steering the language in the wrong direction. They never suggested alternatives. Should we all write custom event loops? Let's see what they talk about here. This is my very biased opinion, but I know I'm not alone in this. I think async brought unprecedented amounts of complexity into an otherwise still manageable language. Async will be the end of Rust, if we let it. Making run timeless and sync programming that's fully safe and zero cost and lets you share references without shooting yourself in the foot is no easy feat. In the meantime, every other language and their cousin implement the basic version of async, paid a little runtime cost, and called it a day. Why is Rust paying such a high and still ongoing price? So that we can pretend our Arduino code looks like Node.js? I do have in cast, I want to have async, obviously, right? And my async is going to work differently. I'm wondering if I will have like some problems. But I will need to solve them anyway. It doesn't even have to do anything with async. Specifically. Like in terms of safety. So like we have the effect system. And async is just working on top of the effect system. And I need to make sure that I don't like leak stuff. But I'm pretty sure it's doable because algebraic effect system and linear types. There is a problem with it for sure. What is this? Hold on. Algebraic effects, another mistake carried through to perfection. Hold on a second. Effect systems are all the rage these days. What all the hype is about. Think of resumable exceptions. Now back to the program. Oh yes, effect types. This has been a smattering of vaguely connected notions. It may not be clear how... What? Hold on. I'd argue that some Zen of Python's rules apply here. Explicit is better than implicit. So like our effect system is working through the implicit system, sure. I don't think explicit is always better than implicit. At the very least, you say Zen of Python, you are implicitly typing your things. Bad. But even in a typed languages, you don't want to explicitly write the type of every single thing every time. You want to have inference, which is implicit, which makes it implicitly typed. And it's not better to have explicit everywhere. Explicit is better than implicit is just stupid in my opinion. Parameter passing is simple, obvious mechanism that everybody already understands. This also is a stupid argument. If everyone already understands something, does it mean that they don't like that they should never learn anything new? Before people invented functions and the parameter passing, they were programming what, like in like punch cards. Everybody understood that, right? Who was programming? They still invented functions, right? Special cases aren't special enough to break the rules. What do you mean by that? Also, it's already implicit with many side effects. Yeah, we are actually going to be more explicit with the effect system than the most of the programming languages, because in most programming languages the side effects are implicit, and like I mean, implicit can mean different things, I guess. Like they're implicit, they are just like unknown to the compiler, they are invisible, like compiler doesn't know anything about them. Versus implicit as in like inferred, right? Or is it just implicit and inferred a different rule, a different like word that we should use? So our context system is not like implicit arguments, it's inferred arguments, right? That's what I should say instead. Special cases are special after break the rules. Internal node in the call graph involved in a service object aren't all that special, but there's still such a big problem. By threading a service parameter through, I have an obvious tickler to understand where all the function dependencies are. What? There should be one, and preferably one obvious way to do it. I don't think this is right. What do you guys think about this one? This should be one, and probably one obvious way to do it. I think this is wrong. It depends on like what you're writing. Take as an example this simple thing. You want to be able to call a function, right? You want to be able to call a function. So you want to be able to print hello world, or you want to like say some string and then you want to print it. It depends on like, sometimes this will make code more readable, sometimes this will make code more readable. If you have the argument before the function or after the function, as like the simple example, I think this is stupid. If there is only one way to do something, the compiler can infer it. True. If the implementation is hard to explain, it's a bad idea. Yeah, maybe. So no good points actually here. But yeah, I was looking at something, right? The algebraic effects and linear types, they don't like sometimes work that well, because in normal effect systems you have the continuation object, and if you just don't use it, then it means that you are dropping everything, right? I mean, I guess in a language like Rust, where you don't have linear system, it would just drop everything. Maybe it could just work. But with linear types, it would be more difficult, because you cannot just drop a continuation anymore. It's wholly impossible and restricts and needlessly. You only get arguments. Aliasing formidability cuts your wings. Okay, so they have the skill issue with the borrow checker, right? Am I right? Skill issue with the borrow checker? Figuring out Rust wasn't for me, took a while. What? I think that for most unyieldingly pragmatic game developers out there, Rust simply isn't the right tool for the job. Rust is about the ideals, all above or else, all else. Those ideals are safety at any cost, performance except when it would conflict with safety, and then if there is room, maybe ergonomics. Safety for them, safety is up there at the top. But I value ergonomics over performance. Only one performance, then it doesn't shatter ergonomics. Okay. I mean, I would agree with that, I guess. I do like ergonomics more than performance. But how does that mean that we shouldn't have a borrow checker? Having no borrow checker and having like issues because of that is not ergonomic. C++ is quite ergonomic. No, they are talking. They like C# in the end here. Rust is all about what you cannot do, and I just want to carefree do stuff. Yeah, and by the way, like if we're talking about cast, we're talking about like what we cannot do to a next level, where in Rust any function can panic, and Rust any function can like access the IO, and now Rust any function can do anything, right? So we're taking this to a whole like other level, similar to Haskell and the monads, right? So in that sense, we are making an even worse language. Imagine calling Python ergonomic. Yeah, I don't think Python... A lot of people say that Python is easier to prototype in than in Rust, but I just don't know, I just don't agree. I like to think about that differently, more than favoring ergonomics performance. Make performance more ergonomic. Yeah, sure. But just like to like the reason they say it, like say in Rust, you always had, I don't know, you only had like boxed function, boxed din function traits, right? Like why do you need in Rust? You have like these function types. You have a function pointer type, then you have a dedicated function foo. If you have function foo, then it has a dedicated type. You have a function pointer type, and then you have the then the din fn trait. So like it would technically be more ergonomic if all you had is like just a single thing, right? And this is what I have right now in cast. Will I need to do something like this? Maybe. But that will make it less ergonomic for sure, right? How do you make and because of that, like you write a closure, and then like you need to box it or something. Instead of just creating a closure. I don't know. There are ergonomics problems for sure, which are because of performance. But maybe it can be made more ergonomic for sure. Maybe. Despite the roast in the previous section, I actually liked many things about in Rust, still do. It ticks many of the small boxes, although not as many as the big ones. The goal here was not fully abandon the ecosystem I still held dear, to contribute back and give the community what I considered at the time would be the solution, Rust Perfect Companion. We're talking about the language. So here is the language, which is powered by LLVM because of performance. No stable ABI, but a predictable one. Fully interoperates with Rust. Rust-inspired syntax. No borrow checker. Value types come first. And if you want references, you have like reft. Sure. Duck type generics. What? No trades generics, nor any of the complexity clusterfuck that comes with those? That's just plain old boring C++ type templates? What? Why do they want that? That's wrong. Singly threaded. Modern tooling. Pound. All right, and I think they like basically they made their own programming language that has those things. Maybe is the language that never was. Or did they not implement it even? I don't know. They were going to implement it maybe. And then they lacked the motivation or something. Then making a compiler is tough. And so they ended up going to C#. Right? That's the thing. That happened. No, it's not a line promotion thing. No. They ended up going to C#. Because the Sharp language server is good. It has the type system. And it has value types. And has metaprogramming. And they have hot reloading, so it ticks all the boxes. But there is, not everything is an expression. The web is not there. Performing debug builds is not there. And there is no exhaustivity checks. That's what they're missing. Oh no, it's a promotion for the game, for sure. Yeah. This is a game. Isn't? Wait, hold on. Is this game made in C#? It is now written in C# with Monogame. That's what it is, the promotion for. Carrot Survivors. All right, what did we get useful out of this? I think their chapter 1 is good to think about what we want in a language. I definitely agree with that, but we have most of this thing. I don't have custom metadata. I do need this. I agree that we need this to add this custom metadata. Reflection at runtime. No. And then like hot reloading is useful to think about for sure. Borrow checker is bad, and we should all flee. C# good, but then also not good, but written in Monogame. But Monogame is also not good. Like, do some people ever come to conclusion that there are trade-offs and settle down? So what was their biggest issue with Rust? I mean, there are big issues in Rust, which are obviously the compile time. And then there is the borrow checker. Obviously, right? But if you want a language without the borrow checker, do they talk about ref cells? They do make it in their own language. RC ref cell. So the ref cell is not really there. You just get to mutate the earliest refs however we want, and it's liberating. So like you can just do that in Rust, right? Why didn't you do that in Rust? The language that never will __. The language that will never suck is the language that we're making. Yeah. It's called cast. But it will never suck. Right now it sucks because it's not implemented fully, of course. yeah, like for those people who don't want to do the borrow checker too much, isn't it just enough to have a type? I think the problem with Rust, for the like, if you want to not worry about the things, is that how verbose it becomes. If you have a function which has like variable which is like, you know, rc ref cell or whatever, right, then you cannot just say f.x is like 1, right? You need to do f.borrowMut or something.x is 1. So can we have in the language support for this, which would automatically like do that? So in Rust you have the dref, right? And drefMut. In Rust you have dref, which is allowing you to have like you know, like cell type into a reference to t, and you have drefMut. This allows you to have a mutable reference to cell, basically, into a mutable reference to t. What is missing to support this is basically a mutable into mutable cell into a normal reference, right? You want to be able to keep your mutable reference for a little while, avoid the bookkeeping. I thought you only needed ghost cell. No, ghost cell is just like improving the borrow checker and allowing you to have more code. It doesn't allow all the code. You still want sometimes to like write code in this way, even if you had the ghost cell. What is missing is mutation of non-exclusive references. So how do you imagine this, Raymarch? I mean, no. We want this over here. Cell to mutable, right? The like non-exclusive reference, and we want to be able to mutate it still, right? That's what we want. And this is something that's missing from Rust. I mean, this over here is implemented in the form of the borrowMut, but the problem is that it is explicit to much, right? So it should be like similar to gref, but allows you to get hold of the reference, right? So basically, if you have a RC ref cell, or let's say that even you have like, I don't know, garbage collected stuff, right? You want to mutate foo here. I just want to be able to write, like, you know, foo, which is a mutable reference to foo, which is just getting from this, right? This would automatically like dereference and allow me to have the mutable reference to it. But this is not just a normal reference, because when we drop it, then we like, I don't know, like we like unlock the thing. Can mutable reference be dropped the last time it is used? And avoid bookkeeping to have syntax sugar. Yeah, so like in Rust also, if you have, let's go back to RC ref cell. So for RC ref cell, you just have these, this instead of mut foo becomes ref mut foo, right? And you say borrow mut. So this is the first problem. It's like, it's becoming like weird. And this is also very verbose. But then this thing is going to be dropped at the end of the scope. Unlike normal references with known lexical lifetimes, that they basically get dropped on the last usage. So I think there should be a feature where we should automatically insert the drops on the last usage too. Let's say I annotate foo to be mutable through shared references, so that the compiler knows that X is not needed for mutation, but that it also cannot make any assumptions that help this case. Is that like going to actually work? But like, why would you just do this for everything? And when you say you annotate foo to be mutable, you basically get the OCaml mutability then. But the way it works, you have like what, mutable field, right? You have a type which has a mutable field inside. This is basically just syntactic sugar to say that stock is basically like a ref cell int. That's literally what it is in OCaml. But they have like syntax sugar for it. Maybe that's all we need, some syntax sugar? I don't know. Can you have no reentrant refs to... Yeah, so I guess it's a little bit different because they don't allow you to store the reference. It's basically, it's not a ref cell, it's just a cell. So you don't have the ref types with it. You can just like either get the current value or place a new value there. There's only two operations. You cannot get the reference, which is like locking mechanism. Anyone, anywhere, tell me. Hello. Isn't the issue just like the verbosity and we need some syntax sugar? That's my question. Maybe. Ref cells are not reentrant. Yeah. But you know, don't need like the reentrance property if you have just a cell. Because you're not like having, like, because you're not locking it. Right? Mutability always have to be so deeply integrated in the language, or can it be just another trait? It's not a, like, mutability. The problem is that it's not a property of a type. I mean, in OCaml, this is a property of a type, basically, right? Can I mutate the book? I can always mutate it if I can just have a reference, because we don't have mutable references, right? But in Rust, mutability is not a property of a type. It's a property of a place, right? It's a property of the binding of a variable, not of the type. Which makes more sense to me. You consider just auto inferring letmut. The atmut thing is where it's at. Yeah, I guess like for the bindings it doesn't matter. We can treat all of the places mutable, sure. But yeah. Right, anyway, you know what? I'm streaming for too long. I need to go. I need to go. Alright, I did improve something in the language today, right? What did I do? An error occurred. Stupid thing. Git log. The terminal is not fully functional for some reason. This is the wrong repository. We have auto-instantiating of the type and have the type of. Oh, did you see the type inspect example, Raymarch? Look at this. type inspect. So we have like a macro, which is running code at compile time with x as the argument. And then when we generate the code based on the type of x here. So we want to know what the type of x is. So we just compile the type of body expression here to know what the type is, and then we generate code based on that. That's something that Rust cannot do, right? Do you have question mark syntax sugar? No. What should it be the syntax sugar for? For passing the errors like in Rust, but those are supposed to be passed without the explicit question mark automatically. That's the current design, at least. All right, Farmer2729, hello, hello. But I'm ending the stream, so... so also bye. Did I push? I did push, all right. I just need to eat. I haven't eaten in 7 hours. End to end, anyway. Rate Tikodev and tell him to close Twitter and chess.com and work on his language. Right. Oh, you see, lesbian monad is there, of course. Alright. Do you understand Tikodev stuff? It's like... oh, here's in a meeting anyway. He's not going to talk. Yeah. Like sometimes when the dude actually talks about stuff, it's nice. You know? It would be nicer if you talked more about the things that he's doing, for sure. You understand 10% of the words. Well, I also don't understand everything, but I started to understand more since I was like reading some books, right? Okay, what is this? What's happening? Hunting bugs in Twitcher. Sure, you want me to go here? I just ask the guy some stuff and he replies sometimes. And then I understand stuff. You just need to ask, basically. You don't ask, you will not understand anything. All right, bye.